When it comes to building information modeling, content is king. Your projects will only be as good as the data and objects that you put in them. But you and I both know that certain items just require custom treatment. And the Family Editor is amazingly powerful and allows you to build just about anything you can imagine. In this course, I'll get you started on the right foot by going over the high-level big picture concepts first. Then we're going to dive in and create some annotation and model families. We're going to make those families parametric by introducing flexible dimensions, materials, and visual characteristics. We'll explore several different kinds of parameters to control length, angle, driving array quantities, and inputting useful product data that we can report in our project schedules. We'll even look at creating advanced formulas and conditional statements to reduce data input, drive complex relationships, and prevent our families from failing on bad input. So if you're ready to take your Revit projects to the next level, then the Family Editor awaits you. Let's get started. If you are a premium member of the lynda.com online training library, you have access to the exercise files used throughout this title. The exercise files are in a folder called Exercise Files that I've placed on the desktop. You can place yours wherever you like. Within that folder, we have several subfolders containing the files for each chapter. There's also some general files that I use across several chapters. Within the chapter folders, you'll find the files that I use for each movie within a particular chapter. You can follow along with these files, or you can use your own. If you are a monthly or annual subscriber to lynda.com, you don't have access to the exercise files, but you can follow along with your own work. Let's get started and create some families. All elements in the Revit software belong to families. Family is one of the most fundamental and basic building blocks in the software. When you create your model, when you interact with views, when you add annotation or configure your project settings, in all cases you're interacting with a family. Therefore, in this lesson, we're going to define the term family as it applies to the Revit software. So let's start with a basic definition. I pulled this from the help file. Families are classes of elements that belong to a category. Family groups elements with a common set of parameters or properties, identical use, and a similar representation. Different elements in a family may have different values for some or all of the properties, but the set of properties, their names, and their meaning must all be the same. That's from the help file, but that's a pretty good working definition of the word family. We're going to start with that, and now we're going to talk about how that definition or how the concept of family fits into the broader hierarchy of the software. So at the top of that hierarchy, we have categories. Categories are also built into the software. They're fixed and pre-built. You and I can't actually change the categories in any way or add categories. They include things like walls or doors or roofs or stairs or pipes or ducts if we were talking about MEP, or beams and columns if we were talking about structure. So there's a broad list of categories that we have to choose from. Each category will have families associated with it. So that definition that we just discussed sort of fits in here next. So if you remember, the first part of the definition was that a family was a class of elements in a category. So it comes next on the hierarchy. But even at that level, a family is still a pretty broad thing. It defines overall characteristics, overall behaviors, but there may be several more specific behaviors or characteristics of each family. We refer to those as types. So each variation of a family that we want to save and use over again, we save that as a type. And then finally, the actual objects in the model are the instances. So we could work this hierarchy going down the chain, or we could actually work it backwards. So we could say that an instance belongs to a type. That type in turn belongs to a family, and the family is part of a broader category. So here's a quick example. The category would be doors. The family comes next. That's single flush in this case. And then finally, 36 by 84 would be the name of the type. We don't see the instance listed here because the instance is the actual thing you would click on in the software itself. So that gives us a working definition of the term family and how it fits into the overall hierarchy of the software: category, family, type, and instance. But as you're no doubt aware, there are actually several kinds of families. And in our next movie, we're going to look at the 3 overall kinds of families. So in the previous movie, we discussed how everything in Revit belongs to a family, and that nearly every action that we perform in the software involves manipulating a family in some way. In this movie, we want to discuss some of the important distinctions between the various kinds of families. Specifically, we have 3 kinds of families, and we're going to look at each one of those basically here in this session. This will help set the stage for the rest of the training series. The most important concept to understand is that there are essentially 2 overall classifications of family: those that we can edit and those that we can't. So let's start with the system family. The system family is built into the system. You and I cannot edit a system family. They come from the factory in the software that way, and we can configure certain settings and so on about system families, but for the most part, system families are what they are. You and I cannot customize them in any way. The next kind of family we have is an in-place family. Now, an in-place family it's a very special case of the family. It's meant to be for one-off, unique situations in your model. I'm going to talk about that more in just a couple minutes. And then the third kind is the component family, or sometimes called the loadable family, or sometimes just family. So it goes by a few different names, but really for the majority of the training series, when we talk about working in the family editor, we're really talking about that third kind. Those are the kinds of families that we have complete flexibility, complete freedom, and we can build them, customize them, create them completely from scratch. What I want to do is go into Revit here, and I want to show you an example of each of the three kinds and talk about these just a little bit more carefully. Over here on the right-hand side of the screen, I have a floor plan. It's a pretty typical floor plan. And you see some examples of walls that are on screen. And walls is a great example of a system family. Walls are built into the software. What it means to be a wall in Revit is predefined by Revit. You and I can't customize what it means to be a wall. Now, let's not confuse that with wall types. I certainly can select a wall, choose different types off the list. I can go to edit type. I can even duplicate and create my own types. I can do that with walls. I can do it with floors. I can do it with roofs, any kind of system family. What I cannot do with the system family is edit the family in any way. Notice there's no edit family button up here. I can't go into the family editor and create a wall family. I can't load in a wall family from an external file. If you go to the Home tab and click the Wall tool, there's no Load Family button over here. So those are the things you're looking for. If you're not sure whether it's a system family or a loadable family, those are the things you're looking for. Contrast that to the door family. If I click the Door tool, there's a Load Family button. If I click the Window tool, there's a Load Family button. The Column tool, Load Family, and so on. If I select one of those kinds of elements, like a piece of furniture or a door or a window, you would see an Edit Family button. Those are loadable families or component families, or again, just families. Those are the kinds of families that we'll be working with in this training series. We mentioned in-place family. In-place family is the third kind of family that we can work with, and it's a special case. It is editable. It is a family that we can modify and customize and build our own. And I have an example of one right here, this sort of curved casework item here that you can see both here in the floor plan and over here in this 3D view. You have this sort of curved condition. It would be very difficult to define that item all by itself in the family editor without the surrounding context, without knowing that there was a certain curved wall there, without knowing exactly how much space was available and how many pieces of casework we could fit within that area. So that's a pretty typical case of where you would choose to go to an in-place family. But the caution is, an in-place family is completely unique. If I were to take this in-place family and copy it around to other locations in the project, I would actually be creating completely new instances of the family. They wouldn't just be types like they would be with a component family. So if I made a change to the first one, it would not ripple through and change the other copies. So it's very important to understand that. An in-place family can be just what you need in a case where you have a very unique and one-off condition. But if you use it thinking that you're going to then be able to copy it around and manipulate it, you may be surprised when you find that it doesn't behave the same way as other items do, and you don't get the benefit of being able to make the change in one place and see that change ripple throughout the rest of the software. Not trying to discourage you necessarily from in-place families. This is really the only time we're going to talk about them in this training series. I want to put them out there in the interest of completeness so that we know that in-place families is one of our three kinds. They do have some interesting possibilities. But for the most part, when we talk about families in this training series, we're going to be talking about loadable/component families, items that we build in the family editor and then load into other projects. So in the last few movies, we've been discussing the difference between the system families and the so-called non-system families, component families, loadable families. They've had a lot of different terms. From now on in the training series, we're going to refer to anything that we can manipulate in the family editor simply as a family, just to make it a little bit easier. In this movie, I would like to focus on two major classifications between the so-called component or loadable, or as we just said, families that we can modify in the family editor. And that would be the model families from the view-specific or annotation families. Now, this diagram that I have on screen sort of encapsulates all the different kinds of elements that are available in a Revit project. And some of these are strictly in the project environment, some are in the family environment, but it does a pretty good job of summarizing at a high level how everything fits in. On the model side of the branch, we can see that it branches into two subcategories of host elements and component elements. Now, host elements is really just another name for system families, and so those aren't the ones we're going to be talking about. You can see from the diagram it's the walls, the floors, the roofs. The component families is the loadable families, or the ones in the family editor that we're going to be talking about, and those are our model elements that we can put our hands on, that we can touch, that are part of the building. So if I clarify, both host and component elements are real things that you can touch and represent actual objects in the project that represent real things, but it's only the component side that are the ones that we can actually manipulate in the family editor. So for the coming chapters, those are the ones that we'll be looking at. We'll be building furniture examples. We'll look at some door examples. We have a few different types of families that we're going to focus on the component side. But they all represent real things in your project, actual objects that either get installed in place or built in place. On the annotation or view-specific side, we're talking about descriptive items that get added on top of the view that are not real things. You don't actually build them, but they describe your design intent. They describe what the drawing is showing in further detail and make it easier for the end user of that drawing to understand what they're looking at. Those include symbols, tags, text, or dimensions. Now, text and dimensions are actually system families, so we won't be manipulating those in the family editor. But tags or symbols are things that we can manipulate in the family editor, and those will be among the first examples that we look at together in the family editor in the next chapter. Detail components are also on this side of the branch, and so those are also view-specific items that can be manipulated in the family editor as well. Now, I haven't really highlighted the middle part of this diagram because, for the most part, those items are not families that we can manipulate. They are important and they are in our software, and we manipulate and work with those in our projects all the time, but they're not things that we'll be discussing in terms of the family editor. However, reference planes on the datum element branch are going to be very important, and so when we get to our model families, we'll talk about that a little bit more. As we can see in this diagram, there are many different kinds of families, but only certain ones really concern us when we're talking about the family editor. And for the most part, they break into these two overall classifications of model versus annotation or view-specific families, and that will really be the focus of the majority of this training series, with the larger focus being on the model families and a small focus on the annotation families. Annotation families can be any graphic or symbol that you use repeatedly in your projects. We can break this down into two basic classifications: annotations that report data from the model and those that don't. A north arrow would be a good example of an annotation family that is static and does not report data from the model. A door tag would be a good example of one that does report data from the model. In this movie, we'll look at a few examples of each. Let's start with what are annotation families. We've discussed this in the previous chapter a little bit, but an annotation is always a view-specific element. Here on screen, I have a few examples. I have a door tag, I have a window tag right here, there's a center line symbol, and so on. If I were to come down here to level 1, right-click it, and choose Duplicate with View, I can choose to duplicate it with or without its detailing. Detailing is another word for annotation, right, or view-specific elements. So I'm going to choose Duplicate, and what you're going to see is the only items that are left behind are the items that are actually model elements. So all the stuff that disappeared, that was the annotation. And all of those are families in one way or another. They're just different kinds of families. This and this is a tag family. This and this are just generic annotation families. This is another tag family. This is also a generic annotation family. So they fall into these different classifications, if you will. Let's start with generic annotation. A generic annotation, we actually have 3 examples on this screen: the center line symbol, the north arrow, and this little align symbol are all considered generic annotations. Now, everything I'm showing you on screen comes out of the box in the installed Imperial library from Autodesk. So the center line and the north arrow were already part of the project, but both of those could be found if I went to Load Family and looked under Annotations. You would see them in this folder here. North arrow is here. There's two versions of it. And the center line symbol further up, right here. And the one that I have back here on the screen, this align symbol right here, that's actually not an align symbol. I wrote the word align in there. It's actually a more generic symbol. It's just called label annotation. And there are three variations of it. One that's set to 1/8 inch tall text, another one 1/16 inch tall text, and the third one 3/32 inch tall. I brought in the 3/32 inch for the example that you see on my screen if I wanted to bring in the 1/8 inch tall. So after I'm done loading it, I can go to the Annotate tab, and I can use the Symbol tool on the Annotate tab to actually place that thing. Now, generic annotations, probably the most challenging aspect of working with them is the terminology. We load a generic annotation symbol, or we create a generic annotation family, but we use the Place Symbol tool in order to actually place it in our projects. So you can see here, here's label annotation, and when I place it, initially all I get is a question mark. So I had gone in there and typed in the word align. I could also type in a note here, and this particular family is set up with that label being a type-based parameter. So it's going to ask me if it's okay to continue, because what I've actually done is created a type modification there. And then I could certainly click on it and add the leaders, and it would behave much the same way as my align symbol. In other words, a generic annotation is really just a symbol that can either be static graphical information like this north arrow or like the center line. The CL in that case is static. It's not something that I could modify. Obviously, the north arrow is graphics. I can't modify that. There's no text to modify. And in this case, it's got a label. So a label is a piece of annotation that I can actually manipulate directly within the symbol. Now, the tags also use labels, okay, but the labels and the tags are a little different. Here, the tag was just a generic placeholder, and I was able to type in anything I like the word remove finish or the word align. Here, the designation is actually part of the host object, in this case the window, or in this case the door. So if I select my door and I come over here and change this to another designation, the tag responds immediately. If you open both of these items in the family editor, so let me take the tag here and do Edit Family. This piece of text is actually a label. You can see from the tooltip on screen or from the tooltip down here on the status bar when I hover over it, it says the word label. That is a piece of text that's actually linked to some property in the model. We call that a label in the family editor. If I switch back to my sample floor plan here and open this family instead with Edit Family, this is still considered a label, but here they've even left the word just generically label because they don't really know how we're going to use that label. It's really for any purpose we want. It's more generic, and it's not attached to anything in the model. Okay, so just some different kinds of annotation that we can create and work on. So a tag is associated with a specific kind of object, and a generic annotation is not. A generic annotation is just a basic symbol that we can really fill in any way that we like. The process of creating either kind of annotation family is pretty straightforward, and that will be the focus of the next movie. Now that we've explored annotation families, and we've seen many possibilities that exist that can accommodate nearly any Office standard, it comes time to turn our attention to model elements. Most of the families that you're going to want to create are probably going to be model elements. Using the Revit Family Editor, we can not only model nearly any geometric form, but we can base the geometry on rules, constraints, and other logical relationships. We call this making it parametric. Parametric families are the heart of what makes Revit so powerful. So in this chapter, we're going to lay down the foundation of the skills that we're going to need to begin making fully parametric component model families. And we'll start that with just an overview of the process. So the first thing is deciding what you need. This can take the form of hand-drawn sketches, look at other objects and mark them up. You can download things and use those as a basis, whatever process you use, but you identify the need, you decide how you want the item you're going to create to behave, and you document that in some way, either through sketches or other forms. When it comes time to actually jumping into Revit and using those sketches that you've determined, there's a couple key things you're going to be deciding. Now, we saw in the previous chapter, Creating Annotation Families, that when we first create a family, it takes us to the Family Templates folder. When we go to the Family Templates folder, we're actually choosing two things when we're doing a model family, where with the annotation family, we're really only choosing one. With the annotation family, we were just saying what category of annotation we're creating. But here with the model family, we're also choosing the category from the template that we select, but we're also choosing the hosting behavior. So what is the hosting behavior? Well, some families require a wall host. Some families require a ceiling host or a floor host. If you choose a template that requires a host, then the family you're building will be required to be attached to that kind of a host element when you put it in a project. So it's a pretty important decision, and you're being forced to make that right away at the beginning. So it's something you want to think about carefully before you get started, and we'll see some examples of that shortly. Once you're in the family, the next step is laying down the reference planes. Now, you can think of reference planes as really the framework or the formwork, the skeleton. All of these words kind of mean the same thing. Formwork determines the shape and extent of poured concrete, and the skeleton, of course, determines the shape and the form of our bodies. And so whatever form, scaffolding sometimes people use, whatever analogy you use to represent the reference planes, they literally are determining the overall form and behavior of this family. We're going to then add parameters and constraints to that formwork, and that's what's going to give us the smarts or the flexibility in our families. So another way we call this is making the family flexible. That's going to mean that it can adjust and change shape and move in size. So we do all this sort of pre-planning and setup before we finally get around to building geometry. So building geometry may be one of the first things you think you're going to do, but it's actually one of the later steps. We want to get everything set up and established correctly first, and then go in and actually add the geometry. If you've got a properly structured formwork and setup, adding the geometry becomes much simpler because it will relate to that formwork that you've established. And then the most important step of all is to flex your model or test it out. Okay, so if we're making a family flexible by adding constraints and parameters, then the process of flexing it just simply means that we're actually going to put it through its paces and make sure that everything is working and behaving the way that we expected it to work. Those are basically the overall things that we need to consider. It's essentially like the back of a shampoo bottle at this point, lather, rinse, repeat. So once you've done these steps, you just do more of the same. And so in the next movie, we're going to go in and we're actually going to perform these steps, start creating our first model family, and we'll be doing that throughout the course of this chapter. It'll actually take several movies for us to build our first model family. So let's get into our inventory of forms. We're going to start with an extrusion. The extrusion we've already been introduced to in the previous chapter. It's a basic sketch-based form. You draw out a shape, any shape you like. It does have to be an enclosed shape, so you can't have any open chains of lines or anything, but it doesn't have to be a regular shape. You can make it any irregular shape you like. And you actually can create holes in your extrusion by creating more than one form nested within one another. The only rule is each form has to be closed and they can't overlap one another. But as you can see from my illustration here, it's just basically a form with a height. So that height is actually numeric. You type it in, so it's not something we draw. So we're only drawing the one form. So to illustrate some of the features of the extrusion, I'm going to create a brand new family, and this is going to be a throwaway family. I'm not actually going to save this at the end, so feel free to follow along in any file you like. I'm going to just use a generic model for this example. A generic model is sort of a non-category. It's good if you're really not sure what category you need or if the category that you are thinking of doesn't really exist in Revit. So I'm going to tile the windows, zoom them all. I just did WT for window tile and ZA for zoom all. So we've discussed reference planes and work planes, and we know that the view that we're active in will help establish that. For this example, I'm going to just work in plan view. I don't really care so much about the work plane. I'll go to extrusion. And we're going to look at these different shapes here. So we've done rectangles already. Let me just switch to maybe something a little different. So I'll do a polygon. The default is 6 sides. I'll draw it right here at the center and maybe out to a 2-foot radius. What I've been doing up until now has been ignoring the depth parameter. That is controlling how tall this extrusion is. And so you do have a few options. You can actually change the depth before you finish the form. Maybe I want this to be 4 feet tall, so I can plug in the number 4 here before I click finish. And you'll see that the height of this thing will be a little larger than what it has been previously. But of course, you can always change that depth later. The depth is also expressed here on the properties palette. So this is something we haven't really looked at too much before, and I'd like to kind of discuss this now. We have talked about the work plane in other movies. So in this case, we see that the work plane is on the reference level. The extrusion itself, the height of the extrusion, even though it's expressed as a depth right here, is actually 2 numbers. There's the extrusion start and the extrusion end. So if we direct our attention to one of the elevation views and I start fiddling with some of these numbers, you'll see how this behaves. Suppose I set the extrusion start to -2 feet and click apply. What will happen is if you look down in the front view or the left view at the bottom of my screen, you'll notice that this extrusion has just dropped below the ground plane. And if you look on the options bar, you see that the total depth is now 6 feet. So Revit kind of does the math for us. So I can start at any absolute point and I can end at any absolute point. And then the result is just the math being done between those two. So either of these can be a positive or a negative number. So this is one more thing to consider in addition to your work plane is both the positive and negative extrusions. In some of the future movies, we're also going to look at these little buttons over here. I just want to point them out right now, though, and say that this is a way that you can actually link up parameters to this extrusion and make these values parametric. You could put dimensions on the form, as we saw in the last chapter, but if I click this little button here, I have the ability to actually link up a parameter directly to that value. And again, that parameter would be a number, and it could be either positive or a negative number. If I have a reason to do that to drive and control the shape of this form, that's another option that I have available to me. So the way that you structure the work plane, the start point, the end point, all kind of factor into your overall strategy for how you want to build this form. But otherwise, pretty simple, straightforward form. If I create another one, of course, we have really any shape we like, but just remember, the shape must be closed. If you try to finish it before you close the form, you'll get this error message here. So I could click continue and say, oh yeah, I need to finish up my form. And that gives me the extrusion. If I decide I want to cut a hole in this form, I can do edit extrusion and I can add another form inside of it. And then it will extrude as a hollow, basically. You can have as many closed loops as you want inside that extrusion. It's all in the single sketch. But what they can't do is overlap one another. If I took this circle and I did this and I try to finish it, Revit will complain about that too. As long as you make a valid sketch, really pretty much any shape that you like is acceptable. It's by far our simplest form. Extrusions are the simplest of our 5 forms. We need only the single sketch, as we've seen, to create them and an appropriate work plane. But despite their simplicity, extrusions are widely used in most families and really are the staple of form creation. All right, in this movie, we'll look at the revolve form. A revolve rotates a sketch shape around an axis line. The result is pretty similar to the effect of turning a form on a lathe, and we did an example of that in the previous chapter. So we're going to take a little more detailed look at it right now. So as with the previous movie, I simply have an empty family file on screen here. This was created with generic model, but you could follow along in really any template. All the forms work the same in any template file. The first thing that we want to do is decide what's the most logical view to build this thing in. Now, if I worked in plan view, then I'm going to be spinning around an axis that's going to be within the plan plane. Probably easier to just illustrate than to explain. So click on the revolve form, and you see that there are 2 buttons here, boundary line and axis line. And if you did the previous chapter, then you've already seen an example of this. We have all the same sketch tools that we had for extrusion, so these are pretty common tools. For this one, I'm going to do a simple rectangle, and I'm going to draw it just in plan over here. Then I'm going to switch over to my axis line, and you can either draw it or pick it. I'm going to draw it over here somewhere. Now when I deselect this, what you're seeing is the axis is here, the sketch is over here. So in order to spin this shape around this axis, it's essentially going to orbit around that line, and you're going to get a donut shape or a ring when we're done. When I click Finish, because we're working in plan and it's spun around this axis, it's actually spinning up towards and away from me. And when you look at it here in 3D, you see that I sort of have this ring shape that's been created vertically. Elevation is probably the easiest way to see this in the front elevation. So the shape that we drew was here, and it spun all the way around the axis that was right there. Now if you edit the form, you can edit either the shape or the axis line. So I could come in and change the shape, but I've got to make sure it's enclosed. If I tried to finish right now, I'm going to get an error. Just like we saw with extrusions, the revolves have to be closed shapes. So I'll make sure that I snap that over here, and I click Finish, and we still end up with a donut shape here, but now it's got a little taper to it, as you can see. It's following that new form that I created. Let's edit it again. What would happen if I took the axis line and moved it a little closer? Well, now I get a much tighter circle. Naturally, if I edit it again and move it further away, I get a much bigger ring. And perhaps I change the angle, and you'll get a ring at another angle. So you can see, without changing work plane at all or really doing anything to the overall form itself, just by changing the axis line sketch or the sketch of the shape itself, there's a wide variety of possibilities. So part of the challenge when breaking down the form you're creating is to break it down into these simpler forms, like to look at the object that you're trying to build in the family editor and think about which forms it should be constructed from and break it down into those smaller parts. So maybe you can use an extrude for a little piece over here and a revolve for some other piece over there, and then when you bring them together, you get the completed form. In the extrude, we looked at the properties palette and we saw that there were some properties. We saw there was work plane, as we have here, and I'm again using the reference level work plane. But now instead of a start and an end extrusion, I have a start angle and an end angle. So I can do some interesting things right here. What would happen if I change the end angle to 180 degrees? Well, now instead of getting a full circle, I get a half ring. I can put in any angle I like and get smaller and smaller chunks. I can even put in negative and make it go the other way. The concept of work plane and the direction of the work plane that was discussed in the first movie in this chapter applies here as well. The direction that the angle is going to be measured from is going to be in that positive direction of the work plane. If you want to reverse that, you can use a negative angle. But you can do both a start angle and an end angle. If I change the start angle here to 20 and the end angle to negative 45, you see what starts to happen. It starts down here and then it goes past and ends up over here. So the work plane is in the middle somewhere, but by changing the two angles, you can influence the way the overall form gets created. And then in a similar fashion to what we saw in extrusions, these forms can also use multiple shapes. Same rules apply as long as the shapes don't intersect one another. And now I've carved a hole in the middle of my form there. So that's our revolve form. A lot of similarities to the extrusion, but it rotates along an axis rather than extruding along a straight path. So let's go to our fifth and final form, the swept blend. The swept blend is sort of a combination between the sweep and the blend, thus its name. We get two shapes, two sketches, one for the start and one for the end, and then they move along a sketched path. So it's more like a sweep because you get to sketch the path. I'm going to start here in a generic model family like the others, go to my Home tab, and click the Swept Blend tool. Like the sweep, we're introduced with a couple ways to create the sketch. We can either sketch the path or pick the path, and in this case I'm going to do sketch path. One little challenge that we have with the swept blend is that the path has to be a single segment. So that's a little bit of a limitation, right? If If I draw with a straight line, then that's it. It's just a straight path. It's basically a blend, which would make you kind of wonder what the usefulness of this would be. Well, let's undo that and look at one of the other shapes here. For example, a curve. Now, if I do that, we start to see that, okay, now we're getting a form that we wouldn't really be able to do with a normal blend, because a normal blend would just go along a straight line. So you do get some flexibility, and we'll do a few other examples in a moment. If we look over here in the 3D view, what we see is two of these green planes, where previously with the sweep we only saw one. So we're actually going to have two shapes that we're going to sketch, and like the normal blend, it will transform from the one shape to the other along the path, which is curved in this case. If you look here on the sketch panel, we see that there are two profile buttons. We've got profile 1, profile 2, and they can both be by sketch or they can be by loaded profile. And as I mentioned in the sweep movie, we will be doing profile examples in a later chapter. So we're going to stick with sketches for now. So I'm going to choose Edit Profile for the first sketch. I'm going to keep these sketches fairly simple, which means I should be able to work relatively successfully here in the 3D view. But what you start to see if you look at each of the views is if my sketch was more complicated and required a little bit more precision, it would become rather difficult to work on it in any of the views that I have available to me. Down here, I'm skewed to the angle of the plane. Here, I'm skewed to the angle of the plane. The plan, obviously, is not a choice at all. 3D is okay, but it's not fantastic. Well, let me finish this and switch to the second profile. Okay, so I'm just going to click this button and do Edit Profile just to show you one alternative that we have here. If I click the Modify tool, if I click this Viewer button, it's called the Work Plane Viewer, you'll get this secondary window here. I'm going to move it out of the way. I'm going to make it a little larger so I can actually see what I'm doing. And now you can see that I'm looking right at that plane. If the angle of the plane is not conducive to giving you a proper sketch, then you can use this Work Plane Viewer feature and it should make it a little easier. Let's do something a little different this time. I'll draw an oval. So we're going to transform from a circle to an oval along that curved path. So we've just got curves in every direction here. Now you can close the viewer whenever you're done with it. You can see the path here. I can click Finish. So now I have my first sketch, my second sketch, and my path. And one more time, Finish again. And there is my swept blend. Maybe it's a piece of ductwork or something. I'm not really even sure what that is. It's a horn. But there's that curved form. So that's the basic concept behind the swept blend. All right, so getting back to the issue of the path, it's somewhat limiting this notion that we can only have a single segment path. But if you're somewhat creative, and I go to my swept blend, sketch my path, then you'll notice that you do have some other choices here, like my spline. And it might take a little bit of effort here to build this, but if you're a little creative with your choice of path, it actually is possible to create a much more complex path and get around the limitation, the multi-segment limitation, because technically this is a single object here, this spline object. So I'm going to click Finish, and this is now my path. Come over here. And again, I could use the Work Plane Viewer if I wanted to, but in this case, I'm just going to use some really simple forms. Click Finish and Finish again. And it is definitely possible to get some fairly complex forms even working within the limitation that the swept blend imposes on us with the single segment path. You just have to be a little bit more creative about it. So that's our 5 overall shapes. Any of those can be solid forms or void forms. And so in the final movie in this chapter, we're going to look at all of the forms together, both solids and voids, and compose them all into a single unified design. In this movie, we'll return to the basic table family that we created earlier in the course. Family is parametric with flexible dimensions, but little else. Parameters are not limited to just dimensions. In this chapter, we're going to look at some of the other kinds of parameters that are available. We're going to learn how to add family types and a variety of other ways to make our families more robust. We're going to start pretty simple in this movie by just talking about identity data. If we go to the Home tab and locate our Family Types button, we've previously been in here to flex our family with our dimensional parameters, and you can see those listed here. Beneath that, you're going to see an identity data grouping. Now, this grouping is part of the default template. And if I come over here to the right-hand side, there's these little triangles here, and I can click on that, and that will expand the group. And you're going to see things like model and manufacturer and URL. These fields are built into the family from the family template, and all the model families have these. So we can simply come in here and start inputting data, like perhaps the model number for this is TBL123, and the manufacturer might be Office Systems, and perhaps it has a website that we want to put in here. I wouldn't recommend trying to go to this website because I'm making it up. And perhaps that's the cost. So we fill in this information. But there may be other information that you're interested in knowing about this family or attaching to this family that you also want to add here. So right in the Family Types dialog, we can actually add additional parameters. Now, previously when we added parameters, we did it from the dimensions directly on screen. But when I click Add over here in the Family Types box, I get pretty much the same window that we saw before with the slight variation. Previously, the type of parameter was filled in for us and it was grayed out. That's because we started with a dimension on screen. When you do it this way, you get to choose the kind of parameter that you want to create from this available list here. Now, I'm going to start with something really simple, just a text parameter, and put it under the identity data so that it falls in with all of the other items that I've added here. And perhaps I want to just have a little text field here that's going to alert my team as to whether or not I've finished with this family yet. I could put in something like progress. What I'm intending somebody to put in here is, is it in progress? Is it finished? Is it complete? This is like a text field that I'm going to use to alert my team as to what stage this family is at. I'm going to assign that at the type level because if one instance of the family is in progress, then they all are. So it wouldn't make sense to have this go instance by instance. So we'll go ahead and put that in there. And over here, I'll type in progress because we're clearly not finished with this guy yet. And we'll click OK. And we've now added that bit of data to this family. When you create your first families, it's easy to focus on only the geometry and kind of forget about the data. But remember, the data is the I in BIM, and it is often as important, if not even more important, than the graphics. Identity data is already a part of every Revit family template, and we can add additional data as required. So make sure to consider this kind of non-graphical data that you will frequently wish to track in your projects, and be sure to include those in your families. We've taken many trips to the Family Types dialog to flex our family as we've refined it. But why is it called the Family Types dialog anyway? In this movie, we'll take a look at the answer and create some family types for the custom family. It's called Family Types because we can save all the collection of parameters that we create here in the Family Types dialog and give it a name. And that actually becomes a type for our family. So a type is really just a saved and named variation of our family. When you're working in a project and you open up the type selector and you're choosing a type, what you're actually choosing is a saved variation like you see here on this list. So all we have to do here is come over here to the New button, click on that, and give a descriptive name to this. Now the default convention used by Revit is to name the family type based on the overall dimensions. So that's the strategy that we'll employ here. The width of this family is 4 feet, so I'm going to describe this one as 48 inches by the length, which is 6 feet, 72 inches. Now, if there was some other important defining characteristic that I wanted to include in here, I could certainly add that to the name. But I think in this case, those are the two most important parameters in this family, so I'm just going to include only those two in the name. And that describes the one that I have here. Now I'm going to click New again, and I'm going to create another size. So I'll call this one a 40 inch by 84 inch. Click OK. And now I need to make the numbers actually match the name. Simply naming it doesn't actually flex it. You've got to make the numbers match. So this is 40 inches. This is 84 inches. I am putting the inch symbol because otherwise it will be 84 feet. Keep that in mind. If the longer size required a different leg inset, I could make that modification here, but I'm going to leave the same leg inset and height. But I am going to come down here, and based on the previous movie where we talked about identity data, I'm going to change whatever data here is appropriate to change, such as the model number, which instead of a 1, 2, 3, let me make these model numbers now a little bit more rational. How about a 40 by 84 for this, and perhaps there's a slightly different cost for this. It's 850. I'm going to apply that, and you'll see in the background in all my views that the dimensional parameters did flex, so that's good. And then I'm going to open this up and return to the other size. Go ahead and click Apply. You'll see it flex again. And I should probably take this model number now and make it match the new standard that I've decided on. So we'll apply that one more time. Let's go ahead and add one more type here. I always like to make a square one. So let's do a 48 by 48. Put in a size there. Modify this. Click Apply. And again, everything seems to be flexing correctly. So now when you want to flex the family, it's a simple matter of opening the list, choosing the size you want, clicking Apply, going to another size, clicking Apply, and everything flexes for you. So it definitely is going to save you a little bit of effort to the previous approach where we were going in and changing each and every parameter. The more parameters you start to get, the more tedious that becomes. So it's usually a pretty good idea to start adding some family types once you start solidifying the family a little bit. In the previous movie, we assigned materials to the geometry in our family. As we saw, the family editor usually contains very few materials from which to choose. In this movie, we will look at ways to address this situation. We have basically two options. We can create the materials directly in the family editor from scratch, or we can copy and paste them from other projects. Now, I've reset back to the default version of our table family here to illustrate the process. If we look at the Manage tab and click on the Materials button, you'll see that the default template starts with very few materials. There are just a few that are named default and so on. So there's very little in here. If you wanted to create your own material, you really can't click New. There's no New button. What you have to do is select an existing material, so one of these really simple ones that are either just a plain color or something or other, and down here at the very bottom there's a Duplicate button. You'd click Duplicate, and then you'd work your way through the tabs over here to modify the material to suit your needs. It's not necessarily difficult to do that, but you run the risk of creating redundant materials because there's a pretty good chance that the material you want already exists back in the project environment. So I'm going to restore my sandbox, which is minimized down here at the bottom of the screen, go to the Manage tab, and take a look at the materials in here. And you can see that we have quite an extensive list of materials. Again, there's a pretty good chance that the material I'm looking for is already here on this list. The challenge is, how do I get a material that's already predefined from this list and bring it over to my family environment? Unfortunately, there's no import-export button in this dialog anywhere. That would be the ideal scenario. Revit does offer a command here called Transfer Project Standards, which you can also find on the Manage tab. The trouble with Transfer Project Standards is you can choose which category of item you want to transfer. Here's materials. It doesn't offer me the list of materials and allow me to pick and choose. So it's either all the materials or none of the materials. So I go from having a very lean family with just the 3 or 4 materials that it starts with to a family that suddenly has 200 materials when I only needed 2 or 3. Transfer Project Standards is not a great option either. So let's talk about the solution, right? We either have to create the materials from scratch, that's no good. Transfer them all over, that's no good. What are we going to do instead? Copy and paste is usually the best scenario because you can select just what you want from the one file, copy it, and paste it over to the other file. Trouble is, there's no copy and paste here. You're not going to get a copy and paste in the materials dialog. So what you have to do is sort of fake Revit out a little bit. So we're going to go to the Home tab. We're going to click on the drop down of the Component button, and you're going to find a Model in Place option here. And this is going to run the In Place Family Editor. So it's actually possible to create what we call an In Place family and build it directly in our project. Now the category you choose here is not important for this example, so I'm just going to choose Generic Models. The name is not important. I'm just going to accept the default name, generic model 1. The drawing will gray out, and it puts me in the family editor, and you can see kind of similar family editor tools that we've been working with all along. I'm going to create a simple extrusion. I'm going to just make a box, and I'm going to make it a rather small size, a foot and a half, something like that, and I'm going to finish the box. Now, if I zoom in, I've just got this simple little piece of geometry. Come over here to the Properties palette, and just like we learned in the previous movie, I can click over here in the By Category list, open up, choose a material that I want, like perhaps here under Metals, I can choose Metal Chrome. Select OK, and now I've assigned a chrome material to this box. Now this box is really just a carrier. Think of it like an envelope. It's the UPS guy. I'm going to select this thing, do Control-C, that puts it on my clipboard. Then I'm going to switch back over to my family here and just anywhere do Control-V, and I'm pasting that box into this other family. I'll finish the paste, and now if I go to Manage and I look at my material list, you're going to see that metal chrome has been brought over to this family. So it's a little strange as a process, but it works. It's effective. It's much better than doing transfer project standards and bringing in hundreds of materials you don't need. And it also is much nicer than having to create the material completely over again from scratch. A little bit of a workaround, yes, but it's effective. The trick is, though, really important, I have to be in the family editor when I do it. So that was why over here in the sandbox, we made sure we went into In-Place Family first. You can't just simply grab a wall or some other object and copy and paste that between the family. If you try and do that, Revit will complain. If I try and grab an object here, do Control-C, and switch over to my family, Revit will complain that you can't copy between a family and project. So make sure you're copying from family to family, and it will work out just fine. An interesting property of all the solid forms in the family editor is the visible property. This property appears as a checkbox on the Properties palette, and it makes the selected element invisible. Now at first you may wonder, why would you bother to create a solid element only to hide it by unchecking the visible checkbox? Well, in most cases you wouldn't do this. However, like all the properties on the Properties palette, the visible property can be controlled parametrically. Now this opens up all sorts of useful possibilities. So in this movie we'll explore a really simple example of when you might want to use this powerful feature, and we'll see some other examples throughout the training series as well. So I'm back in my table family. I've got a version of it called Visibility, if you're following along with the exercise files. What I'm going to do is use the visibility parameter to take this keystone that we've been working with on top of the table and make it optional. So I'm going to create some versions of the family that show the keystone and other versions that don't. So when you're flipping through your product catalog, you can buy it with the power option or you can buy it without the power option. And so we'll be able to check and uncheck that option. So that's our goal here. So if we look over here on the Properties palette, we're simply going to control this checkbox right here under Graphics, Visible. You can see there's a checkbox right here. We're going to control it parametrically. If I just uncheck it, it's off all the time. If I leave it checked, it's on all the time. But if I use this button right over here on the right-hand column, I can control this object's visibility with a yes-no parameter. So a yes-no parameter just controls a checkbox. If it's yes, it's checked. If it's no, it's unchecked. So let's click Add Parameter, and I'm going to give this a name. It wants to group it under Other by default. I tend to prefer to put that under Graphics. It seems like a better place for it, but you can really put it under any one of these categories that you like that makes sense to you. I am going to control this as a type parameter because, again, I'm assuming that this is an option that I would purchase out of the catalog that way. I either want to buy it with the keystone or without. Click OK, and click OK again. This will gray out the visible parameter. It'll put an equal sign on the button to let us know that that's now being controlled parametrically. And otherwise, there's not really any other clues that you'll have on screen that this is being controlled parametrically. Now let's do one other thing. Let's return to Family Types, and let's add a new type to our family that uses the keystone setting. Now you'll see under Graphics, here's our Show Keystone parameter. And for all of my existing types, it defaulted to On. So I'm going to switch to the type that I want to create, 48 by 72. Click New, and that basically copies the existing one. I'll call this 48 by 72 no keystone. And click OK, and then just simply uncheck the box. When I click Apply, what you'll see is over here in the 3D, it just simply grays it out. The family editor does not actually make it fully invisible. If it did, they're concerned that you wouldn't actually understand that the object was there. So in the family editor, it just simply grays it out. That's the way it conveys that the object's actually invisible. To really see it truly become invisible, you have to load it into the project. Let's switch to another family type here. Apply. You see it comes back to full intensity. So it is working here in the family editor. Let's go ahead and OK this and load it into the project to really test it out. So here we have our sandbox project loaded again. I'm going to simply place a version of it right here, and let me place another one right next to it. I'm going to select the first one. If I open up the list, you'll now see a no keystone option is available on the list. And already here in the plan view, you can see the keystone has disappeared. And if I open up my 3D view of the conference room, you can see that one of them shows the keystone and one of them doesn't. So this is a really simple example of controlling the visibility of an object with the yes/no parameter. This is not the only place that a yes/no parameter can be used. We can use it for other things as well, and we'll see some other examples later in the training series. But the use of the yes/no parameter to control visibility is a powerful way to add variation to your family types that would otherwise only be possible by creating duplicate and often redundant copies of the entire family. In this movie, we're going to talk about subcategories. Subcategories are a feature that allow you to have global control over various settings across multiple families. Now, they can be a very powerful feature. It can also sometimes be a double-edged sword if you're not used correctly. So working here in a simple file, let's take a look at the subcategory feature. In this file, I have just some doors from the out-of-the-box content. Double door and a single door and a few other examples here. Each of these doors has some common components. They all have panels, they all have door swings. And if we zoom in a little bit on these doors, what you notice is that each one has a panel and a door swing, and the panel in each case is slightly darker than the swing is, even though this is a family called double flush, this one's a family called double uneven, and this one over here is a family called single flush. Now, each of these families uses the subcategory feature to control those internal subcomponents. The best way I can show you this is to take a look at the visibility graphics dialog. So I'm going to type VG. That's going to open up visibility graphics, and we see a list of all the built-in categories in Revit. Now, next to each category, there's a little plus sign. And if I expand that, we see any subcategories that belong to that category. And the list of subcategories that we see for doors is a pretty logical list that's pretty self-explanatory. Most doors have an elevation swing. Most doors have some sort of a frame or possibly some glass or a panel or a plan swing. And what you see is that each of these items has been given a subcategory, and then furthermore, those subcategories have been assigned various settings like projection line and cut line and so on. And we can even turn those subcategories on and off. So the easiest way I can illustrate to you the benefit of the subcategory is to simply turn off the plan swing, click OK, and then back here in the drawing, we notice that all the swings have turned off even though they're scattered across several different families. If we didn't use the subcategory feature, we would have to build in some sort of a visibility parameter into each separate family and then control each family independently. The subcategory gives us the global control to do it across all of them. Except for this guy over here, right? This one's throwing us a little bit of a curveball. We've got this dashed line over here, which I would assume would have been plan swing. Let's take a look, VG. It turns out that that one's been assigned to the elevation swing subcategory. Now that seems a little odd to me in a plan drawing, and therein lies the challenge that we have with subcategories. Despite everyone's best intentions to make things more flexible, more universal, and more global, if they're not planned out very carefully, you can get into problems. You can have redundant subcategories, you can have categories that aren't named very well, And so this gets into the realm of CAD standards and BIM standards and being very careful about the way that we assign these things. And it's even more acute when you look at some of the categories that aren't quite so obvious or aren't quite so easy to define. Doors are pretty easy to define, but what about specialty equipment? Well, if we looked at master spec, we would find that specialty equipment includes a whole host of things. Kitchen equipment, ladders, fire extinguishers, protective coverings, you name it, all falls under specialty equipment. The challenge we have is if manufacturers of each of these kinds of items create their own subcategories for each of their types of equipment, we could end up with a very long list. Furthermore, if they don't agree on what to call those things, we could end up with not only a long list, but we could end up with a long list with a lot of inconsistencies. So for example, if I were a manufacturer and I wanted to create such a subcategory, how would I do it? Well, I can access the Object Styles dialog either from the Manage tab on the ribbon or directly right here from VG. That will give me the same list of categories. Looks a little different. Scroll down. Here's Specialty Equipment. I select it, and then I click the New Subcategory button over here. Give my new subcategory a name. For example, earlier in the training series, we began creating our awning family, which we're going to look at further in later chapters. That would be under protective covers in the master spec. So if I'm the manufacturer for that piece of equipment, I might want to create that subcategory. I just simply click OK there. And now I have that subcategory. I could assign a line weight to it, a color, line pattern, even a default material. So these are all the default settings for that subcategory. When I click OK, you'll now see it listed here in the VG dialog for each view. And then it would be up to me to assign the components in the families to that subcategory. So when managed carefully, subcategories can offer a level of control not easily attained through other methods. But do, however, exercise caution and restraint when creating and maintaining them, and just talk it over with your team and make sure that you're following a clear and concise and consistent CAD/BIM standard. In an earlier chapter, we explored the 5 geometric forms that we can create in the Family Editor. All 5 forms use at least one sketch to determine their shape. 2 of those forms, however, the sweep and the swept blend, offer an alternative to drawing the sketch directly in the form. They can instead use a nested profile family. Profile family is just a 2-dimensional closed shape. You can use them to draw any shape that you wish to apply to the sweeps and the swept blends in your families. The advantage to using the profile family is that common typical shapes can easily be reused and shared among multiple forms and even among multiple families. So I have my table open on screen that we've been working on in the last several movies, and we're going to create a profile that we're then going to sweep around the edge of the table to kind of represent a molding maybe, or a sculpted edge around this table rather than just a square cut. So to start, we're going to go to the application menu and we'll highlight new, and we're going to create a new family. Now we've seen this box before. Here's all our family templates, and if we scroll down, we will notice that there are several profile families. We have just a generic profile family template. We have a generic hosted template, a mullion profile, rail, reveal, stair nosing. So obviously these are very specific. This is the one you would use if you were creating a mullion. This is the one you'd use for a railing, for a stair nosing, and so on. You have 2 choices here for profiles that can be used in more generic situations. A hosted profile is really what you would use if you were creating a wall sweep or a wall reveal. Little difficult to see in the illustration over here, but there's some text on there telling you where the wall would be versus where you would draw your profile. So there's just some little text cues there. For our case, to just create a profile that we're going to use in geometric sweep in a family, we can just simply use the simplest one, the simple generic profile family. So we're going to go ahead and open that up, and it will open up a single view, and you're looking at what should now be the familiar 2 reference planes, center front back and center left right. The intersection of these 2 reference planes is the insertion point of the profile. So we're going to see that that's actually going to be important when we use this profile shape in the family. I'm going to zoom in a little bit, and I'm going to imagine that this intersection is the corner of the tabletop. So I want to draw the shape that I'm creating relative to that point and that tabletop edge. Let me go ahead and maximize this up. If you look at the ribbon here, you could see that because we're in a profile family, this is just a 2D family. It's kind of similar to the tag family that we created at the start of the course. You only have 2D shapes here. You can bring in lines and detail components, and that's about it. Well, lines is all we need. We can draw any shape we want. I'm going to click that tool, and you can draw a line or a rectangle or polygon or circle, whatever shape you want your profile to have. So I'm going to start right here, and I'm going to move over maybe about 1.5 inches. I'm going to come down, zoom in a little bit closer. I'm going to come down about 1/2 inch, come over a little bit, maybe switch to a curve, and I'll just draw a little curve shape here, and I'll end up with a line. We can use this shape as either an additive shape or a subtractive shape when we use it back in the family. I've kind of drawn it with a subtractive shape in mind, but it really could be used for either one just by simply rotating it and flipping it. The whole point of a profile family is it's meant to be a little bit more universal. If you want, you can actually add dimensions here, and I can try and lock down the sizes a little bit. So I could start to put dimensions on here, and you can even take these dimensions and make them parametric if you want to. Now, for this example, I don't really need to do that, but what the advantage of that would be is I could then go to family types, and I could add types to this. And so if this same basic molding shape came in 2 or 3 or 4 different sizes, then using all the same techniques that we've learned elsewhere in the family editor would apply here. We could place the dimensions, label those dimensions, and then create types. For this example, as I say, I'm going to keep it at just the one size here, so basically doing a one-off. And let me save it as a family, and I'm going to call this table edge. And I will then load it into my project. And that will take me back to my table family, and we're ready to start creating solid or void forms from this profile. And that will be the subject of the next movie. So in the previous movie, we created a profile family that we're going to apply it as an edge to our table using a sweep. We can do this in one of 2 ways. We can take an additive approach, or we can take a subtractive approach. With an additive approach, you can literally think about how this thing would actually be built. It would be as if somebody took a molding and was going to actually attach it around the edge of the table. If rather they were going to take the edge of the table and put it on a router and cut away the shape of the edge, then it would be more of a subtractive approach. So if we want to do it additively, we would use the sweep command. And if we want to do it subtractively, we would use the void sweep command. And I'm actually going to demonstrate both in this movie. So let's do the sweep first. And when I choose that, it's going to put me in a sketch mode. And I'm going to maximize up my 3D view here just so that I can get a good look at what we're doing. The first thing you need to do with the sweep is determine the path. So you can either sketch the path or you can pick the path. I'm going to choose the pick path option because it's more convenient and it will keep the path associated with the edge of the table, which is what we ultimately want here. So I'll choose pick path, and then you can just reach in and highlight the edges of the table. The first edge you pick, you want to use a little bit of strategy on because you'll notice that's where the plane of the profile is going to go. So this green dashed box represents where the profile goes. So it's more important if you're going to sketch it because that's the plane you'd need to look at in order to sketch this profile. In this case, because we're using a profile family, it's not as important, but you still probably want to plan it out. So I've picked all 4 edges, and that gives me the sweep path, and I'm going to finish that. Now I'm still in the sweep command. I've just completed the path, and now I have to tell Revit what I want the profile to do. If I want to sketch the profile, then what I would want to do next is get a view that looks at this plane here, at that point, and then I would want to choose this Edit Profile button here. And that would put me in sketch mode and give me all the normal tools, and I could draw the profile in place. But because we've created the profile and loaded it into this family in the previous movie, when I open up the list here, you will see Table Edge is already here on the list. If it's not, if you forgot to load it, you can come over here and click Load Profile, or right here and click Load Profile. Same thing. And that will take you to a dialog box which will allow you to browse out to your hard drive and find the profile family that you want. So because we already have it loaded, I'll just choose it off the list. And if I zoom in here, you can see that I intended this one as a subtractive edge. So it's oriented within the thickness of the table family. Well, for this first demonstration, I'm just going to kind of flip that because we're treating it as an additive edge, as a molding that we're tacking onto the tabletop. So let me go ahead and do that. Click Apply, click this Finish button right here, and then you'll see the sweep added around the edge of the table. Now, the only disadvantage to doing it this way is, as you can see, this has actually increased the size of the table. If I return to my floor plan view, you can see that that will definitely have an impact on the way we set up our parameters. Notice the length is referenced back to this edge inside, and now the edge is 1.5 inches larger all the way around. So I'm actually going to delete this profile because we're going to reapproach this in a subtractive kind of way. Okay, so I'm going to go back to my 3D view and essentially repeat the same process, except that this time I'm going to do it as a void sweep. So when I choose void sweep, I get the same options. Pick path. I'll do the same table edges. Finish that. Go to the Modify Sweep tab. Choose Table Edge as my profile. And you'll see that it's oriented correctly here. And when I finish, the way that a void works is when it's selected, it kind of looks solid. But if I deselect it, you'll see that it immediately applies to the solid geometry here. And so this edge has now been applied to the edge of the table and is cutting away from that material. And if I look at it from plan view, we haven't actually added to the overall length or width of the table. Profile families offer a convenient way to create both solid and void sweeps. Creating the profile externally in a separate family is easier than sketching it in place directly in the sweep. As we demonstrated here, the same profile can be reused in both solid and void forms, giving it an additional advantage. So we've created a profile. We've added it as both a solid and then changed it to a void. There's one more key advantage to using profiles. If you decide you want to edit the shape, you can simply reopen the profile family, make the modification to the shape, and then reload it into any family that's using that profile, and all of the solid forms or void forms that are using that shape will update accordingly. If I zoom in here on the profile edge, the edge I drew is a little bit large for the thickness of the table. So I'd like to actually keep essentially the same shape, but I want to reduce the overall size of the shape so that the edge isn't quite as dramatic. So I'm going to come over here to the project browser, expand families, scroll down and locate the profiles, and here's table edge. And I'm going to right click on that and choose edit. And that will reopen my table edge family here and take me to the shape that I drew earlier. And what I want to do here is just simply take these shapes and maybe reduce it a little bit. So I'm going to drop the size of this circle down to about a 3/4 inch radius. And I'm going to drop this guy over to about 1 inch, and then perhaps take the entire shape here and move that up just a little bit. I'll kind of half that size a little bit. So I've essentially got the same shape, but I've just compressed the entire shape down, and it now fits into this 1x1 shape right here. And I'll reload that into my project, and I will get the now familiar family already exists dialog, and I can overwrite the existing version or both the existing version and its types. Now, again, in this case, I don't really have any types, so it doesn't matter so much which one I choose. Okay, so I'm going to choose the bottom one in this case, but either one would give me the same result. And you can see that the profile has immediately updated to reflect that change. A little tough to see here, so let's change the scale. That'll reduce the scale of the line weights there, make that a little bit easier to see. One of the main advantages of using profile families is simply their flexibility, that you can go back to the profile family at any time, open it up, make a change, and then reload it into each of the families that use it, and the forms that are referencing those profiles will immediately update to reflect the new change. Architectural communication involves many abstractions and established industry drawing conventions. In many cases, the way we draw something in plan views is different from how we want to see it in elevation or in other views. In this chapter, we will look at several ways to vary element display under different viewing conditions. We will start in this movie with symbolic lines. Symbolic lines are two-dimensional drafted lines that display in views parallel to the one in which they were created. If you draw them in plan view, for example, they will only show in other plan views in your project. Likewise, symbolic lines drawn in elevation will only show in other elevations that are parallel to the one in which they were drawn in. Symbolic lines provide a handy way to convey drafting conventions that would otherwise be difficult or impossible to model. Perhaps the easiest way to start looking at symbolic lines is to start with some of the out-of-the-box families. And a great example is door families. Almost every door family that comes with Revit uses symbolic lines in both plan and in elevation. So I'm going to select one of the doors here. This is just the standard single flush door, and choose Edit Family. Now, when you come into this family, it kind of looks like we're looking at an elevation view. This is actually the 3D view. See how I can actually orbit it in 3D. And if we look over here in the project browser, under 3D views, you'll see that view 1 is bold. So that's the active view. Where we're going to see the symbolic lines is in floor plans and in elevations. So let's go to the ground floor plan, zoom in a little bit, and you'll see that this arc right here, this is just a simple arc. And if I hover over it, it is a symbolic line. Likewise, these lines right here are just symbolic lines. And if we open up one of our elevation views, we'll find the same thing. That this line work here, this dashed line and this dashed line are both symbolic lines. Now, some of the stuff is 3D geometry, so this is the actual 3D geometry, but they're using the symbolic lines here to represent the elevation swing. So let's do a variation of this family. Let's save this family under another name and change it a little bit. So what I want to do is, for the two bathrooms that we have back in our project, I want to show that there's a louver down at the bottom of the door. Now, there's a few ways we could approach that. We could actually model the louver three-dimensionally as a full-blown 3D model. That might be a little bit overkill. It would be a little bit heavier, it would increase the file size, and it might show too much line work, and it wouldn't look so good when we print it or when we display it at smaller scales. So instead, we could make a simplified two-dimensional version of this louver just to represent that it's there in the views that need it. For example, in the elevation view. So we'll use symbolic lines for this demonstration. But it might also be nice to at least indicate that there's something there in 3D and other views, but perhaps not in all the details. So what we could actually do is we could start with a model line to represent the outline of the louver, and then use the symbolic lines to show the additional detail. Now, in both cases, whether you're drawing a model line or symbolic line, Revit will want to know what plane you're drawing these lines on. So I'm going to do pick a plane here, click OK, and I'm going to draw these lines relative to just the surface of the wall there. Go over here and choose rectangle. And I'm going to do this a little sloppy for this example, and I'm just going to eyeball a rough shape, and I'm not going to set it up parametrically or dimension it. You can do that as an exercise if you like. I'm just simply going to get the general idea across here. I'm going to switch to the Annotate tab, choose Symbolic Lines next, change the line style that I'm using for these symbolic lines to panel in projection. Okay, so I'm going to treat them as part of the door panel, and projection because I want them to be the lighter line weight that I'm looking at. And I'll just start drawing some lines here. Now to speed this up, I could switch over to copy and select this and do a multiple copy. Stop right about there. And that gives me the overall representation. Perhaps need to change the line style right here. This is doors and projection, so let's make that panel and projection as well. And that kind of gives me the rough overall shape, and I should have something that in 3D gives me just the simple rectangle, but in elevation actually shows the more detail of the individual louver blades. Now, I don't want to save this family and update the single flush family. What I'd rather do is to save this family as another family, and we'll just simply add a prefix to the name, RFE, save it, and then load it into our project. I'm going to close these views and get it out of the way. And rather than create a new one, I'm simply going to take these two doors that I already have, open up my list, and there's my RFE single flush. There's the type I want. And when I swap that in, no change in plan, of course. In the 3D view, I'll get the overall rectangle, and here in the elevation, we see the symbolic line version. So as you can see, symbolic lines offer a convenient way to manage the display of view-specific elements in your family content. Often the inclusion of symbolic lines will be coupled with other view-specific display settings. Configuring such settings is the subject of the next few movies. In this movie, we will configure the display of various elements in our family to hide them in certain view-specific conditions. For example, often the 3D geometry will prove too detailed for a plan view. So we can instruct our family to hide some or all of the 3D geometry in plan, and then using the techniques covered in the previous movie, we can draw a simpler version of the object using symbolic lines. So what I have on screen here is the out-of-the-box kitchenette family that we had loaded in our office building before. And you can see that this file is actually made up of several nested families. So it's got the refrigerator and the dishwasher and the sink. And I'm going to take this sink file here, and I'm going to choose Edit Family. And that's going to open that up. And I want to do a little window management here. So I'm going to minimize the original kitchenette here and then open up the floor plan. And let me just do WT for window tile and then ZA for zoom all. And let's take a look at the floor plan here and the 3D view here. And we're going to discuss some of the visibility settings that have been used in this file. Now this file actually uses both symbolic lines that we talked about in the last movie and the visibility settings that we're going to discuss here in this movie. So if we start over here in the 3D view, we have some simple solid forms being used to sculpt the sink. So we have a sweep here for the faucet and just a simple extrusion for the handles and some other extrusions over here, and we've got the bowl and so on. And if you look over here in the plan view, you can see that most of that geometry is actually gray. So if I select this, you see it selects the base of the sink, for example. And if I select this one right here, you can see that selects the faucet. So the geometry that we're seeing in plan is a little different than what we're seeing in the 3D. Now, overlaid on top of that are the symbolic lines. So what they've done is the gray in the family editor represents a hidden element. And we talked about this briefly in a previous chapter, but there we used a visibility parameter. Here, the visibility is being applied a little differently. Here, the visibility is being applied as a view-specific setting. So if I select this 3D element right here, and then go up here on the ribbon to the Visibility Settings button, you're going to see that this particular item has been disabled in plan and reflected ceiling plan views. So it's saying display it in 3D views and only the front and left and right and back elevations, not in plan or RCP. So that's why it's turned gray here in our floor plan. That would be the same for any of this gray geometry. All of it has the plan box unchecked. In its place, they've simply drawn symbolic lines to represent what that geometry should look like in the more simplified two-dimensional version of this family. So when we load this family into the project, what we actually see, and we can kind of see that here if I go back to the host version of the family, is that when I look at this thing in plan, I'm actually seeing a very simple two-dimensional representation of that sink rather than the more detailed, complicated version, which would have double lines around the bowls here and perhaps some lines for the shape of the faucet. It's just a simpler representational view. Now the same has been done over here with this cooktop. The 3D geometry has mostly been turned off, and what we're actually seeing are the symbolic lines. Now if I select this and I go to Edit Family, you can see there's the 3D geometry. And if I look at the plan view here, you can see it's a little difficult to see because the symbolic lines are actually right on top of the reference planes. If I went to Visibility Graphics and click on the Annotation Categories tab, then right here I can turn off the reference planes. And that's just temporary, and that'll make it a little easier to see these symbolic lines that have been drawn here. Now what I want to do is make a small modification to this cooktop family. I think it's great that they've got this simple two-dimensional representation here in plan, and I agree mostly with the notion that we don't need to see this 3D geometry like the blend here, which is using the visibility settings to turn it off in plan. But if you look down here at the bottom, there's also the detail levels. So what I'm going to do here is I'm going to select all of these lines. It's going to take a couple selections to get them all, just using my control key. I'm going to select all of those lines there, and I'm going to go to the visibility settings. And I'm going to tell Revit that I'm only interested in seeing those when I'm set to a fine level of detail. So I'm going to uncheck both coarse and medium. And when I click OK, those lines are also going to turn gray, which is letting me know that there's some sort of visibility condition assigned to those. Here, the view is currently set to coarse. If I change it to medium, they'll still be gray, but if I change it to fine, they'll go back to being solid because I'm only displaying them in that view. Now let's go ahead and load this back into our kitchenette. Click OK, overwrite the existing version, and what you'll see is all those lines will disappear because this view is displaying in coarse, and if I change it to medium, still disappears, and if I change it to fine, it now reappears. Now I'm going to back out just a touch. Here in coarse, you'll see that they actually had a feature like that already built into this family. Notice that there's a label here for dishwasher and refrigerator that only displays in medium or above. So using the visibility settings allows us to control not only how the object displays in plans or elevations, but also allows us to control how it displays in coarse, medium, and fine. And when you get to your project environment, when you change views from either a plan or an elevation or change the level of detail to coarse, medium, and fine, the families will respond accordingly with a correct and appropriate level of detail. Revit determines what to display in a plan view by the View Range dialog. Any element that is at or below the cut plane will display in plan, and typically those items that are above the cut plane will not. There are a few exceptions, notably generic models, casework, and windows. Those three categories can actually display automatically above the cut plane, but everything else cannot display above the cut plane unless you employ a little trick. So the subject of this movie will be how do we deal with element categories that we want to see above the cut plane when they don't automatically buy Revit. And I have one such example here on screen. This is our bracket family that we started back in our earlier movie when we were talking about modeling. If you may recall, at that time we added the swept blend and a few other features to this item. This is largely the same family, unchanged from that point. And its category, if I look up here at the Family Category and Parameters dialog, its category is Specialty Equipment. So it's not one of those three, generic models, casework, or windows, that would automatically display above the cut plane. Now in the background, I have the sandbox loaded. So if I did load into project and I try to place the element, I'll get a warning from Revit saying that none of the elements are visible in this view, and it's giving me several things I can look into and check. I'm going to cancel that. And of course, the reason for that is pretty obvious. This is not one of those categories that displays above the view. And if we look at the north elevation, we can see the bracket is clearly here. It just happens to be above that 4-foot mark. So I'm going to delete this guy and return back in my family, and let's talk about how we can kind of fake Revit out here and make this occur. So the trick involves understanding the rule. The rule is if you're not one of those three magic categories, and if you don't occur at or below the cut plane, you don't display. So what do we need to do? We need to create an object in this family that's either at or below the cut plane. When we do that, Revit will see that object, and then it will trigger the display of this element. The easiest way to do that is to work in my elevation view. I'm going to go to my Home tab, click on the Model Line tool, and I'm going to set the subcategory of the model line to the built-in Invisible Lines category. As the name implies, invisible lines are invisible, and so even though I'm going to draw a line here, it's not actually going to display anywhere in the family. You can see it show up in the telltale gray. That's typically what Revit uses in the family editor to let us know that that object is invisible. So we've got that line there, which now intersects the cut plane, which would occur right about here. And that will trigger the display of elements in our plan view. In the previous movie, we talked about symbolic lines. And so what you can see here, if I open the floor plan in this family, is that all of the 3D geometry is grayed out. I have previously gone in and taken all of the 3D geometry and done the steps that we did in the last few movies to select it and edit the visibility settings and turn it off in plan. And that leaves just these symbolic lines here, and there's a short one at the end that display in plan view. So let's go ahead and load this family into our project and see how we did. Previously brought it in, so I'll overwrite the existing version, place it as a component right here, and you can see that the bracket now displays in plan view, even though when I look at the elevation, it is in fact still above the cut plane. And if you highlight it, you actually see that ghosted in invisible line. So that's what's actually triggering the display. So if you're not one of the three categories Revit displays automatically, and again, one more time, those are casework, windows, and generic models, then the object will not display by default. But if you just employ this simple little trick and add an invisible line cutting through the cut plane directly in the family, you can make those elements display. Any of the concepts covered so far in this course would make for a robust and powerful family. However, the real power of the family editor lies in combining techniques for maximum effect. In this chapter, we're going to take a look at a complex model family design. We're going to look at an awning structure that's held up by a series of brackets, and I have the final version here on screen called Canopy Complete. You can find this in the Finished Files folder of the exercise files if you have access to those. And all I'm going to do in this movie is just sort of walk you through the final results so you have an idea of where we're going to be going in the next several movies. So here's the overall design. You can see it here in the 3D view. And it has several little parts and pieces. And we're going to assemble these as a series of nested families and various arrays. So let's take a look at each one of the families in particular. Now we've already seen the bracket family. Let's open that one up first. We saw this earlier in the training series when we were looking at solid forms. And so just to reiterate how this thing is put together, this guy is an extrusion right here. If we were to edit that extrusion, you would see it's just a simple shape that's been extruded to a thickness of 2 inches. This guy is a sweep right here. So it's just a curly shape here for the path. If I edit that sweep, you can see there's the path right there. And this green line is where the profile was sketched, and that profile shape is, if I zoom in there, just a small rectangle. Pretty straightforward shape there, but makes for a nice effect when it's done. This is also a sweep, a little more complex. It's got a little bit of a curved shape to it. That one is using a profile. So when we click on select profile, there's a profile here called bracket shape, and so that's a nested profile family that's been loaded in. Kind of spin the view around right there. You can get a better look at it. Sort of looks like that. The advantage of using a profile shape there is that that same profile shape can be used for other sweeps like this one, and it can even be used in other families if you wanted to. So if you were going to create several versions of this bracket, you could reuse that profile. For these sort of finials at the end here, we're using a blend with a void to round off the top. So this is just a simple blend between 2 rectangles, and then the top is rounded off with this void form out here, like so. And then there's a revolve here for this little collar. So that's the complex bracket, or just the bracket family. There's also a simple bracket right here. This is when we become victims of value engineering, and they tell us that we can't afford the nice complex bracket. So we'll go to this one, which is made up of just a simple extrusion in this direction, and then the cross brace here is also just a simple extrusion. So not only is it a simpler looking design, but it's also a simpler construction using just 2 extrusions. So we'll close out of that one. I can show you here by highlighting and tabbing. Both of those use that invisible line trick that we talked about in a previous movie to make them display overhead, because both of those are specialty equipment category. The final family is the awning family. Go ahead and edit that one. And it has this glass canopy right here, which is actually a blend. If I do edit base, it starts off as a rectangle. And then if I do edit top, it goes to this sort of eyebrow shape right here at a depth of about 5 feet. Yes, I'll cancel that. And then that gives us this shape here where it goes from flat to this sort of subtle curve shape. And then to round off the end, there's just this void extrusion right here that's cutting off those corners. These support structures here are also just blends. Edit the base, there's just a rectangle here, and edit the top, another rectangle here, which gives it the slight taper. And then materials have been applied. Now, the other thing to point out in the awning family here is it takes into account the thickness of the bracket that we're going to be using. So there's a 1-inch dimension here that's been locked in with a reference plane, and that allows space for that 2-inch thick piece of material there that we're going to slip in for the bracket. And when all these parts and pieces are combined together, we'll end up with this assembly right here. So with that introduction, let's go ahead and get started. In the next movie, we'll begin creating our complex canopy design. Continuing on in our canopy design, in this movie we will add a parametric array and constrain all the parts and pieces. So I've got a file here called Canopy Step 2. You can follow along with me in this file if you have access to the exercise files, or you can continue in your own version that you created in the last movie. So we have our bracket here and we have our awning here, and what we want to do is create an array of both of these, and this is somewhat of a review, but we'll go through the steps anyway. I'm going to start with selecting the object that I want to array, and then I'll click the array button. And as we talked about in previous movie, we can either do a linear or radial. Obviously I want to do linear in this case. I do want to group and associate it because that's what's going to allow me to make it parametric. And I typically just start with a quantity of 2 and adjust it later. I want to make sure that I'm using the move to last option because I basically set these up like bookends. I want my first one and my last one because I find it easier to control that way. So I'll pick my start point and my new point. I've just sort of chosen those randomly at some point. Of course, if I put in some other number, the array would flex and we would see it working from its current position. But what I want to do is actually move these brackets over and attach them to the reference planes that we previously created. So the easiest way to do that is going to be to use the Align tool. I'm going to select Align, and I want to highlight the left edge reference plane as my point of alignment. And if I zoom in a little bit here on the bracket, what you'll notice is that in addition to the edges, which I could certainly align to, in the center of this bracket is a reference plane. That's actually what I want to use as the point to align to. And that will line up the bracket directly on the center of this left edge reference plane, and I'm going to lock that. And I'll come over here and repeat the step on this side, again aligning to the center, and I'll lock that. And then let's repeat the whole thing with this awning. Go to Array, Group and Associate 2, go to the last object, select it, use my Align tool, and this time, again, I want to do left edge. Don't align it to the bracket. We don't want to relate it to the bracket. We want the reference plane in the host family, this canopy family, to control the position of this thing. So make sure you're choosing that left edge reference plane again. And then notice here that there's a reference plane in this family just about an inch away from the edge here. So that's what I want to click, and that makes it line up nicely relative to the bracket. Those two pieces have been designed to fit relative to one another. Let's repeat it on the other side. Right edge reference plane to the invisible reference plane inside the awning. And we'll lock that. So at this point, if we were to flex both of these and adjust the quantity, you would see the quantity change, but those two bookends would stay put there at the end. Now what I want to do next is actually create parameters to control these. So if I select my awning, kind of move my mouse around up here, and look for the array dimension. Sometimes you have to move your mouse around to get it to highlight. We can select that and label it. Let's add a parameter, and I'll call this number of awnings. I'm going to group this under graphics. Again, you can really group it anywhere you like, but I like it under graphics. Number of awnings, it's an integer parameter and it's a type-based parameter. You'll see that label appear right there. Let's do the same thing with the bracket. Again, you might have to move around to find that dimension. Label it, add another parameter. Number of brackets. Put it under graphics. Click OK. So at this point we'll flex it. I've got my family types dialog. Currently I have 2 brackets and 2 awnings. Try some other numbers in here. Click apply, and you can see that it is working. Of course, I've chosen some rather random numbers there, and you can see that nothing really quite matches up except the 2 at the ends. Well, if we look at the overall length here, 40 feet, and we select this guy, you notice the name of the awning within that group is called 60 wide. And if you really want to verify that, I could do a measurement and measure it, and it's 4'10" plus the inch gap on either side. So the overall width of this awning is actually 5 feet. So if we do the math, that means that we really need 8 awnings. And if we have 8 awnings, then that means that we need 9 brackets. One more bracket than we have awnings. And if I apply that, you'll see that everything flexes and it all fits nice and neat, and everything is perfectly matched up with the overall length of the canopy. So that completes the setup of the basic array, and in the next movie we'll look at setting those array values up with a little bit more intelligence using either family types or formulas. So we've made really good progress on our complex canopy design, but we have a few more finishing touches that I'd like to look at. First is we're going to add a family types parameter to control the bracket that we're using and allow us to swap in and out a simple and a more complex bracket. And we're also going to add a flip control so that we have a little bit more flexibility when we're placing the family, and we can actually flip it relative to the wall, kind of like you would see in doors and windows when you're placing those. So let's start with the family types parameter. Here I have canopy step 4 if you're following along, or you can continue in your own file. So I'm going to select the bracket here, and I'm going to edit the group that it's contained in. Now, you may recall that when you create an array, that the array becomes a member of a group, and the group is how Revit is able to associate it parametrically. So groups, when you highlight them, have this little dash box around there. So we can just go ahead and select it, and that allows us to select the group. And then up here on the ribbon, we're going to see the Edit Group button. So I'm going to click on that, and that puts me in Group Edit mode. Now, when you're in Group Edit mode, Revit kind of tints the background with like a yellow color, and of course it shows this big Edit Group toolbar. So those are the 2 ways you can kind of tell you're in this mode. Now here's our complex bracket design over here, the one we prefer, but we've unfortunately become a victim of value engineering, and so we have to provide an option that's much simpler. So I'm going to select this, and I really don't want to just change the bracket completely. Like I could just choose it off the list here and be done with it, but I'm hoping I can convince the boss to stay with the complex one. So rather than just change it outright, I'm going to make it a parameter so that we can swap it in and out on the fly. Now you may recall at the start of this tutorial that we loaded in 2 versions of the bracket. We had bracket and bracket simple as families in this file. So I've got this one selected over here, and I'm just going to go up here to label, choose add parameter. And when I do it this way, Revit will figure out what type of object that is. It's a family type, and it's specialty equipment. If you did it through the family types dialog, you'd have to choose the category off the list. And I'm going to choose bracket type for the name, decide what group I want to put it under, and it'll be a type-based parameter, and I'll click OK. Now, unfortunately, when I do this, Revit is going to generate an error, and unfortunately, these are the kind of errors you don't really like to see because they cannot be ignored. So some of these errors are relatively benign, and you can ignore them, or they give you a few possible remedies. This particular one, you have to deal with it before you can continue. Now, neither option that they're offering is really terribly great. You can either cancel, which basically stops the whole command dead in its tracks and we can't continue, or we can remove constraints. Now, the constraints in particular is you'll notice that it's highlighting our 2 bookends. So somehow Revit is not happy with the constraints that we applied to the bookends, the locking of our family to the reference plane. And, you know, sometimes if you click expand, it tells you a little bit more information. And all it's really doing is confirming that the 2 reference planes are involved and the 2 specialty equipments and some dimensions that I can't really see in this view. So unfortunately, as I said, remove constraints is really the only way that we can continue. But what, of course, that's going to end up doing is when I finish the group, if I flex this family and I choose one of my other sizes, unfortunately, all of my brackets are going to be left behind here. Notice how they all are still flexing. You still have the right quantity, but they've all gotten kind of left behind. So here's the way that I'm going to deal with this. I'm going to go back to the 20 long. And that kind of gets everything back where it was. I'm going to select the first bookend at the end here. And I'm just going to move it off to the side. Then I'm going to select the next one and do the same thing. Basically go back to where we started from before these things were constrained. And then I'm going to just simply realign them. So I'm going to use my align tool, pick my reference plane, find my center line, lock that, reference plane, pick my center line, and lock that. Now that should do the trick. Sometimes you just need to reset things in order for Revit to be happy. Let's check it out. 30 long, apply, seems to be working. Let's try the 10 long, apply, seems to be working. So in this case, we fortunately just needed a reset and everything is now back to normal. Unfortunately, sometimes you won't be quite so lucky. So you'll get those error messages sometimes, and that's half the battle, is learning how to deal with them and walking through the steps to troubleshoot and try and figure out what it's going to take to get the family to start behaving again. Now, I want to add one last finishing touch to this before we complete it, and that is a flip control. This is sort of an optional feature, but it's a nice feature. If you remember that when you add doors and windows, they have those little double arrow flip controls. It makes it real easy to reverse the direction of the door. We can do the same kind of thing with this canopy family here so that we can easily flip it from one side of the wall to the other. So the control is right here on the Home tab. And you actually have several different versions. You can do vertical or horizontal ones. And the single control actually rotates, and the double control does more of a flip, does more of a mirror. So it's the double vertical that we want. And you don't get really any kind of indication from the mouse other than this little tooltip that says click to place the control. So I would prefer a cursor change of some kind, but just click and that will actually place the double arrow control. And be careful not to click a second time because it will actually create another control. Instead, just cancel out of the command or click the modify tool to complete it. And so the final step is just save the family, and then we'll be ready to load it into a project to test it out. And we'll do that in the next movie. So our complex canopy design is nearly complete. We have one final test to go. We need to load it into a project and really make sure everything is working. We could consider this the final flex of our family. We have several things to test. We want to test the overall sizes. We want to make sure the family types are working, and we want to test out our new flip control. If you discover any problems when you load into project, then you just have to come back to the family editor, make adjustments, and then reload it, and so goes the process. So let's go ahead and give it a try. I do have the sandbox loaded in the background, and I'm in a file right now called Canopy Step 5 if you're following along, or you can feel free to use your own version of the file as well. When you load into project, if you don't have a project loaded, Revit will alert you, so make sure you have the sandbox or some other project loaded in the background. And when it switches over to that project, you'll see the little circle with the line through it. And this is because this is a wall-based family. So like doors and windows, you have to actually highlight a wall in order to place this family. And I'll kind of try and position it around a door and go ahead and click to place it in. Now I could continue placing more if I wanted to, but I'll go ahead and cancel out of there. So let's take a look at this and see how things are behaving here. When I click on it, the first thing we'll notice is there's my little flip control. And again, this is very similar to the flip controls that you would see on doors and windows. So let's give that a try. I'll just go ahead and click on it, and you'll see the canopy flips to the other side of the wall. Now I probably don't want the canopy inside the building, so we'll go ahead and flip it back, but that is functioning correctly. Let's go to family types here and try some of the other types. There's our 30 long, seems to be working okay. Let's try the 20 long. So far so good. And here's our 10 long. Let's go back to maybe a 30 long, which seems to be a pretty good size over here. I'm going to come up here to my default 3D view icon and click on that. And let's hold the shift key, spin it around with the wheel, zoom in back here. And what we start to see is that I've got a slight problem there. It looks kind of like the brackets are sort of buried in the wall a little bit. So we could kind of see that in floor plan as well, but it's a little more evident here. So that's why I wanted to look at it in 3D. So we'll adjust that in a moment, but let's just see if the family type parameter is working. Now to do that, remember that that is a type-based parameter. So if I look here on the properties, you won't see that parameter anywhere. But if we select the item, like I've done here, and then click Edit Type on the Properties palette, you're going to see all of the parameters that we've added. Now, canopy length is grayed out. Number of brackets is grayed out. That's because both of those are tied to formulas. So the only way we could actually change those settings would be to dial in a new number of awnings. So that's actually kind of a nice user experience because the end user only has to decide how many awnings they want, and they dial in a number, for instance 5, click Apply, and tough to see from this view with this window open, but it changed the quantity. I think there used to be one more over here. Of course, I'd want to rename 30 long if I was going to keep it this way. So I'm going to change it back to 6 and Apply. You'll see it adjust there. Now here's the bracket. So let's try that one out. Now, unfortunately, here's the downside of family type parameters. We have discussed this in a previous movie, is this is looking for specialty equipment. This project happens to have a lot of specialty equipment. So if somebody's not careful, they could add a bunch of kitchenettes along this awning instead of brackets or bracket simples. So let's do bracket simple. Let's click Apply, and you can see that is working. So let's go back to the main bracket, the nice detailed one. We'll click Apply. And so overall, everything's functioning the way we expect. We just have to make that one simple adjustment there. So let's switch back to the canopy. And I'm going to go to the floor plan level for this. This is actually a pretty easy thing to fix. When we brought in the original components, we just placed them relative to the wall, but we didn't actually lock them to the face of the wall. We just got them nearby. What I want to do is use my Align tool here, and I'm going to change the preference to wall faces, pick up the face of the wall, and then the edge of the bracket, and I'll lock that. And I'm going to just repeat that for the bookends on both sides. So I don't need to do every component. I just need to do the start and end of the array. So I'm going to do here the 2 bookends for the brackets, and here the 2 bookends for the awnings. I'll load that into project, overwrite the existing version, and you should see it shift right there out to the face of the wall. And if we go back to our 3D view, you'll see that it now looks much nicer, except for the part that it's covering over the window. But we'll let the designers worry about that. All right, so let's zoom all the way out here. There it is. There's our completed complex awning design. Congratulations, you've completed a complex parametric family. In the last chapter, we created a complex model family design. In this chapter, we're going to look at a complex annotation family. I'm often asked how to create a key plan in a project. The first techniques that folks usually try is to create a new view at a very small scale and then add that view to the sheets. The trouble with that approach is you can only add a view to one sheet at a time. So if your project has many views and many plan sheets, you're going to end up having to duplicate that key plan several times, and that becomes pretty unwieldy as a solution. The solution I prefer is an entirely different approach. So in this movie, this complex annotation family that we're going to create is actually going to be a key plan symbol. Now, to work from here, I've just sort of created a really simple project file here. So we're looking at a sheet 101, and let's just take a look here what else we've got. We've got sheets 101 through 105, and these represent the sections of the floor plan. So over here in the project browser, this A101 that we're looking at is looking at Zone A, and if I just sort of back this out a little bit and uncrop it for a moment, you can kind of see the overall footprint. So all I did was put the outline of a building here, but you can see where the match lines are. There's several match lines, and we end up with 5 zones in this floor plan because at the scale, at 1/8 inch scale, they would not fit on one sheet, obviously. So each of those has been set up in the various floor plans here, and what we need is a little key plan here to say what zone we're in. So to get myself started, I have created a temporary key plan view here that I called Key Plan Temp, and this is set at 1 to 200 scale. Now if I went to the floor plan and actually drag this view on here, this would be the approach that a lot of folks initially want to try here. You'll see that it's about the right size for a key plan, but again, the trouble is I can't add that to more than one view. So I would have to duplicate it, and like we said, that gets a little bit tiresome. What we're going to do instead is I'm going to trace over this result. But we're going to make sure that we do it right here in the sheet. And this is important because Revit will not let you copy geometry between a project and a family as a rule. But if you trace it in the sheet, you can overcome this and copy and paste from the sheet to the annotation family. If you try to do it directly in the view, it's not going to work. So that's why we're going to make sure that we're doing it here. So I'm going to go to Annotate and click on Detail Line. And it's a little tough to get it. It won't snap, but you can get it close. And again, it's a key plan, so you don't have to be perfect here. You just have to be close enough so that it actually represents the true shape of the building. Now, this might bother some folks, and if that's the case, then you might want to try another technique. But unfortunately, there's no way that I can snap this directly. So the only one that I was off a little bit is right here. So I'm just going to nudge that over a little bit with the arrow key. This one is perhaps slightly off. I'm going to have to zoom in a little to get that to nudge. There we go. That'll do the trick. And then I want to also draw some detail lines for the match lines. So we'll put one here, out here, and it doesn't really matter how long these are. So if I pull them out here, it's a little easier to keep them from trying to snap to the line work that I've already drawn. Sometimes you have to zoom in to do that. So once I have those lines drawn, I want to surround all that stuff. And you want to be careful. You saw that I was trying to find a spot where I could click. If you click here and you drag, it's going to move your viewport. So if you drag from right to left, it's going to create a crossing window and you're going to get the viewport. So I want to do a selection this way so that I only get the detail lines. Okay, and I'm going to copy those to my clipboard. So the next thing I'm going to do is go to New Family. Actually, I'll do New Annotation Symbol. You could do New Family, and that would take you to the generic families folder, and then you could go into the annotations folder. If you do New Annotation Symbol, it takes you right into the annotations folder. So you can get there either way. I want to create this as a generic annotation. I'm going to click Open, and this just gives me a blank page here. And you get the standard note that's telling you a little bit about this family. And I'm going to do Control V and just sort of paste this thing in. Now again, if you had created that geometry directly in the view, Revit would have generated an error message saying you can't paste between project and family. So that's why we did it that way. That's why we drew the stuff in the sheet view first. Where you want the insertion point here is really up to you. If you want it in the middle of the building, then I can take this stuff and I can kind of center it in the middle of the building. If I want maybe down at the end of the building, it really depends on what you think is more convenient to insert this by. So if I want to do it that way, that's fine too. Really doesn't matter so much. This is a symbol now that we're creating, so the precision level of a symbol isn't quite as high as the precision level of model geometry. Let me go ahead and delete this note. And that gives us our basic building shape to start from. So we'll leave it there for now, and in the next movie we will begin creating our key plan family from this basic geometry. Continuing with our parametric key plan family, we've traced over the floor plan from the project file to get the basic geometry in the previous movie, and now what we want to do is take this basic geometry and create a series of filled regions from that will represent the shaded areas of the key plan. So I'm in a file here called Key Plan Step 2, and if you're following along, you can open that one up, or you can continue in your own version from the previous lesson. And the next step that we need to do here is to create some filled regions in the 5 areas of the building. So we're going to use filled region for this. And let's start with the simple ones, right? We can do a basic rectangle right here. There's no need to lock all of these because some of this geometry that is underlying is temporary anyway. So we'll just leave it unlocked. Go ahead and click Finish. And the default filled region style in the family editor here is solid black. If you're happy with that, then we're basically done. Otherwise, you could duplicate that type and do a crosshatch pattern or something if you prefer. The other thing that you might want to consider is, as I zoom in here, let's try and get the filled region here, depending on the line style you chose for the outline of the filled region, and that would be back in the sketch, You may or may not like the rounding of the corners there. Now, the line style just gives us generic annotations as the only choice. And that's, again, because we're in a default generic annotation family template. So if you want to adjust those line weights, you'll have to go to Object Styles, create a new line style, and fiddle with that. Or you can actually set the edges of the filled region to invisible lines and then come back and just outline the overall shape. That's actually what I'm going to do, is I'm going to make those invisible lines, and then later I'm going to make this line work here a nice bold line type. But you can see that that gives me a cleaner, harder edge corner there. Some of this is graphic standard, so if you prefer to do yours a little differently, feel free. I'm going to go back to Home and create another filled region. You can trace over this, you can use pick lines, any technique that you want to do, but I'll just go ahead and start off with invisible lines this time, and it's just as easy to trace this like so, and finish up like that. Now, as you move along, it's all going to turn black, but each of those is a separate region, so it's not an issue. Let's go ahead and just do the next three. And there's our final filled region there. So if I zoom back out, the whole thing is black. That's fine. What we're going to do is get rid of these lines right here. We no longer need those. This one, I'll press the Tab key to get all three little parts. And so we now have 5 separate filled region shapes in here, and we have an outline that goes around the whole thing. So that outline I want to actually be a little bit bolder line type. But again, I currently only have generic annotation as a subcategory. I don't have another subcategory to change there. So I'm going to go to the Manage tab, Object Styles, and for generic annotations, I'm going to add a subcategory called Medium Lines. Now I'm just using the same name that Revit would use in most of the other templates. And medium lines is typically about a pen weight 3, but it's up to you if you want to use a different pen weight, of course, and you could use a different line color or pattern. It's entirely up to you. I'm going to select with the Tab key, again, all of those lines, and now medium lines will be there on the list. And I've just given that a little bit more weight. So the next step that we need to do is we want each of these filled regions to have visibility control. Now, just like in a model family, we were able to control the visibility of an object using parameters here on the Properties palette, we can do the same thing here in an annotation family. So over here for the filled region, the graphics area has the visible checkbox, and right next to it has the small little parameter button. So I can simply click on that. That brings up the Associate Family Parameter box, and the parameter type is going to be a yes/no parameter. It's going to be a checkbox. If it's checked, it's yes. If it's unchecked, it's no. I'm going to add parameter. Now the top region is actually our 5th region, so that is Zone E. So we're going to name that Zone E. You can put it under any group you want. I'm going to put it under graphics, I suppose, and click OK. Now while I'm here, I'm just going to go ahead and add the additional parameters I need. And I need 5 of these. And once you've created the last one, you just want to make sure that Zone E is selected before you click OK. We've created all 5 in this dialog, but we want Zone E to be associated with this filled region. And then we simply want to select the others and associate them with an appropriate zone. So that one's D, this one's C, B, and A. So that gets all our regions set up. It associates a parameter with all of them. And in the next movie, what we'll do is begin creating family types and formulas to actually control which zone is turned on under which circumstance. In the previous movie, we set up our filled regions and assigned them to yes/no family parameters to control their visibility. And in this movie, we're going to go ahead and link up those parameters with a little bit of smarts in the family types dialog so that we can turn on and off the various zones as needed in the project. I'm in a file called Key Plan Step 3, if you're following along, and you can, of course, continue in your own file if you prefer. And I'm just going to slide it over a little bit here so that when I open up the Family Types dialog, give myself some room so we can see what's going on in the background. You can see here in the graphics group, I have the 5 visibility parameters that we set up in the previous movie. And there's really two approaches we can take to this. We could simply create family types, call it zone A, and uncheck all the others and click apply. And in doing that, that's a zone A, and then repeat zone B, zone D, and so on. And that certainly is effective, and we could finish up in just a few minutes, and it would, for the most part, work just fine. I can't help myself. I sometimes like to add a little bit more smarts to these things. So what we're going to do is we're going to use some formulas here to control these things. So again, if you prefer to just do it with family types, feel free. You'll be done before me, but mine will be cooler. Let's go ahead and add a parameter. And the parameter type that I'm going to add is an integer. And I'll put that also under graphics just to keep it all in the same place. And I'm going to call this key plan region. And I'll click OK. And that gives me a number here, a little 0, and a little spinner that I can just toggle through various numbers. And now what I want to do is, unfortunately, they don't have a character parameter type, so I had to go with integer here and use a number, but that's not the end of the world. Now what I'm going to do is, over here in the zone A formula field, I'm going to write key plan region equals 1. When I enter that, you'll notice that it unchecks the box and it grays out zone A. Now, what did we just do here? Well, this is a special case of the if statement. When you do an if statement to control a checkbox, because the checkbox can only have two possibilities, checked or unchecked, you basically describe the true condition. So we say key plan region equals 1. What we're saying is if that occurs, then the answer is yes. So we want the box checked. So let's see how that works. Let's change this to 1 and click apply, and you'll notice that checks the box. If this value is anything else, right, 0, 2, 3, 4, it's not checked because that condition is false. So when it evaluates this condition, if it turns out to be true, it checks the box. If it turns out to be false, it doesn't check the box. If you're doing a conditional like this for any other kind of parameter that's not a checkbox, that's not a yes, no, then you've got to write if, open parentheses, write your condition, and then the condition if true, comma, the condition if true, comma, the condition if false. You've got to do the whole statement. But you can shorthand it to just the true condition when you have these checkboxes. So what I'm going to do here is copy this and paste it and just change the number. I'm doing Control C and Control V here, like so. So now when I dial in a key plan region, you'll see it changes the value. And so that pretty much gives me formulaic control over my key plan regions instead of doing it manually with a bunch of text boxes. And really, who wants to do things manually when you can have a cool formula do it for you? I may still want to create the types to go along with this to have a more complete solution. And that's because I created these parameters as type-based parameters. I could also modify them and make them instance-based. So if you decide that you actually don't want the types at all, and you just want to be able to dial in the instance parameter, you can do that. Only problem is it will complain that all of the other ones are type-based parameters. So I wanted to show you that. This is where the planning comes in. If you want to do it instance, you need to make sure that you actually change all of these to instance. So you can do it both ways. I'm going to leave it as a type-based parameter right now because that's the way I set it up. But if I wanted to, I could modify these, change them all to instance, and then control the whole thing without any types at all. Okay, so now I have all of my zone types and they're being controlled by formulas. So I have the best of both worlds, and I'm going to OK out of here. I'll save my key plan family, and in the next movie, we'll load it into our project and test it out. So our key plan family is complete. We've added all the geometry we need. We've assigned visibility parameters to the geometry and set up types and formulas to drive everything. All that remains is the testing, the flexing of this family. So to do that, we're going to load it back into our project. Now I still have my key plan project open in the background. If you've closed yours, you can reopen it now. And I'm looking at key plan step 4 here. Now when I load it back into the project, you'll see it comes in by that insertion point that I specified. I'm going to place it right there next to the other guy Let's zoom in. I'll do a zoom region, ZR, and I'm just going to remove this view and delete all of this temporary geometry that we created in the first movie. And I'm just going to take my key plan now and slide it over here a little bit. You'll notice that zone 1 is lit up already, and that's because this guy came in zone A by default. If I change it to zone B, it'll switch zone C, zone D, and zone E. And everything's working. So we're all set, and that's our complex annotation family. Feel free to add it to the other sheets if you want and experiment with it further. So in the previous movie, we took the work plane built into our reference line, made it active, and drew the extrusion directly on that work plane. I'm in RFV Door Step 3 file right now. You can open that file if you have access to the exercise files and follow along, or you can continue in your own version if you prefer. The alternative approach that we can use to building the extrusion directly on the work plane is we can nest in a nested family. So to start off with, I'll delete the extrusion, and I still want to keep my reference line. That's going to remain important to control my rotation and other parameters. So we'll keep that reference line. But instead of drawing the extrusion directly on the reference line, we'll bring in a family to use there instead. Now, the first thing I want to do is set a different work plane active this time. So I'm going to go to the Set Work Plane button, and it's currently using the reference level as my work plane. I'm going to do Pick a Plane and highlight the plane that's parallel on the reference line and click on it. And that will make that the active work plane. Now, if you want, you can click Show and see it, but that's a little distracting, so I'll turn it off again. But that just confirms that we've gotten that one set. Now, the next thing I want to do is open up the family that we're going to load in. Now, this family is called Door Panel Flush, and it is a generic model face-based family. So when you open a face-based family, there's a surface sitting here. It's just a generic extrusion, and you use that as the reference to draw your family geometry. Now, if you look at the floor plan, you've got the typical reference planes in both directions marking the insertion point. So it's just a basic family from that respect. The template that was used here was New Family, and it was a generic model face-based. Now, face-based can be a little nicer sometimes than either ceiling or floor or wall-based, because a face-based family is simply looking for a surface. That surface can be horizontal, it can be vertical, it could even be a sloped surface on a roof, for example. So when you build your geometry, if you want this geometry to be perpendicular to any surface, using a face-based template is a good way to go. Now, otherwise, all that's in here is just a simple extrusion. That extrusion uses the same trick that we did in the previous movie, where the 2-inch thickness parameter being assigned to control the thickness, and then otherwise it's got a width and a height parameter. Otherwise, it's a pretty straightforward family. Let's go ahead and click Load into Project, and that'll take us back to our door family. And initially we get the Can't Insert symbol, right? The circle with the line through it. And that's because if you look here on the ribbon, the default behavior is to place on a vertical face. Now what this means is if you were to highlight any vertical face on the screen, like the face of the wall or even the face of our reference line, it would try to place that panel on that surface. Well, we don't want the panel laying down flat on the floor. We want it standing upright. So what we're going to do instead is choose the Place on Work Plane option. And then that will see my active work plane, which is currently the reference line. You can see that confirmed right here on the options bar, placement plane, reference lines. And then what I want to do is, let's zoom in a little bit. I need to match the orientation of this door panel I'm bringing in to the existing reference line. If I simply highlight the reference line and tap my space bar, it will rotate to match the orientation of the reference line. I'm going to tap it again, and it will rotate another 90 degrees, and now it's exactly oriented the way I want. And then I can just simply move down here and snap to the end point, like so. Now, if you need to, you might have to lock that. Let's go ahead and flex it and see whether or not locking is necessary. So let me zoom this out, or I'll just pan it actually over here. And let's try another rotation and another width. And let's click apply. And you can see that it doesn't appear that we need to lock it. It's staying attached to that endpoint that we chose, rotating with the reference line and moving as the hinge point moves. Let's go ahead and set these back to our default orientations and click OK. So the one thing you may have noticed is that the size of the panel was unaffected by the change in width. That's also something that we can modify using this technique, and that will be the subject of the next movie. Continuing with our parametrically controlled door family, in the previous movie we left off by adding a door panel using a nested family, and when we flexed it was rotating and moving correctly, but the size of the nested door panel was not changing. So in this movie we're going to look at using parameters in the host family to drive the values of parameters in the nested family. This can be a really powerful feature that will enhance your nesting of families. Without this, it becomes a very manual kind of process, but with this feature, you can have a great deal of control over the nested families. So let's take a look. I'm in a file here called RFE Doorstep 4. You can open that file or continue in your own version if you prefer. And we have our nested generic model family right here, door panel. And when I click on it, you will see some parameters listed over here on the properties palette. And you will also see edit type, as you might expect, and other properties here. When you're in the family editor and you go to either the property dialog or the edit type dialog that we're in right now, there'll be a third column over here. And several of the parameters have these little tiny buttons. Any parameter that has a little tiny button over here in the far right column, you can link that parameter up with a parameter in the host file. So you can use a parameter in the host file to drive the underlying value in the nested family. So for example, width is one of those parameters that we probably want to drive here. So I can click this little button and I can link up the width parameter in my host door family to make it drive and control the width parameter that's built into the nested family. I can do the same for thickness and the same for height. There may be other parameters that we would want to do that too, but let's start with those three. Let's click OK, and zoom out just a touch, and let's flex. I'm going to come over here. Let's try a new value for at least the two that we can see, which is width and thickness. Let's apply those. And you'll see that as the size of the opening grows, now the nested family actually grows as well. If we change the rotation, it might be even easier to see. There it is right there. And I can reset these back. Let's apply that. And let's just make sure that the height is working as well. Let's actually do that in 3D view. Might be a better view for that. Let's move this over here. Family types. Try 8 feet. Click apply, and you'll see that the door panel is changing height as well. So this feature allows us to link up any parameters in the host family with the underlying parameters in the nested family, and becomes a very powerful way to manage our content so that the host family can fully control any of the nested parts and components. We've done a lot of straight line geometry so far in this course and haven't really looked too much at other shapes. Similar to angles, which could be a little bit challenging, another really challenging form for us is curves. If you're creating a static curve, it's pretty easy to do, but if you're creating a curve that you actually want to flex with your family, it can actually turn out to be quite a challenge. So to illustrate that, I've come up with a little exercise that I'd like to run through with you, and that is creating a parametrically driven brick arch. Now it seems like a pretty basic thing. Anywhere you look, there's brick buildings and many of them have brick arches. But surprisingly, there isn't a real obvious way to do this in Revit. I'm going to start off by telling you the techniques that you could use and some of the common techniques that I've seen, and then we'll jump in and start building the family that I've devised here. I guess we'll call it my favorite option at the moment. Bear in mind, this is still a work in progress. Ask me again in a few months and maybe I'll have a better idea. All right, so a couple ways that people approach it. Sometimes they'll just go into the family editor and they'll just do a simple extrusion in the shape of a curve. The problem with that is, and I actually have an example here on this file, is you tend to get something that looks like that. So while you can get the curve just fine, you're not going to get a material that's going to match that because there are no radial patterns in the software. So that bothered me enough that I started looking for other opportunities. So the one that I've settled on, the one that I like the best, is this curved arch family here, and it's actually using the massing environment. Now, we've done the entire training series in the traditional family editor. We haven't looked at the massing environment at all. But the massing environment is something that was introduced in Revit a couple years ago in Revit 2010, and it's a slightly different environment to the normal family editor. It's still a family editor. You're creating RFA files, but you now have much more free-form geometry. You have different interface. It's a little bit of a steeper learning curve to get into. Fortunately, the massing part of it, I'm going to keep pretty light for this example. Actually, where the meat of this example is going to come from is in the formulas and in the trigonometry that's going to be applied. But we are going to be using the massing environment to get the individual bricks. It turned out that that was the approach that I liked best, and the massing environment gave me a real easy way to do that. So with that as an introduction, let's go ahead and get started with this complex brick arch family. We have all the painful math out of the way, and our armature is complete and it's flexing properly, and that's half the battle. We're now ready to start adding some geometry to this family. To do that, I think it would be a little nicer to do it in the 3D view. So I'm going to open up my default 3D view here, and because we're in the massing environment, let me do a zoom region. You see that it looks a little busier in here in 3D. The massing environment actually shows reference planes. So that's what all of these are. These are actually the reference planes on screen. So be careful about selecting those. If you actually click on them, it makes them the active work plane. So you want to try and avoid clicking something if you don't intend to make it the active work plane. Now, of course, you still have the set work plane button, so you can always be much more deliberate about setting your work plane. But one of the features in the massing environment is the ability to just simply set the work plane just by clicking on a reference plane. Let me zoom in just a touch closer, like so. And to create form in the massing environment, you start by drawing the shape you want and then clicking the Create Form button. I showed you that in the very first movie in this chapter. Also, you may recall that if you highlight a shape in the massing environment, it actually chain selects by default. So right now it's highlighting the entire chain of walls, or this entire pie slice, and it looks really busy. Just remember to press the Tab key, and that's how you can reach in and select just an individual edge. Now, another unique feature in the massing environment is that you can create surface geometry. It doesn't have to always be solid forms like it does in the regular family editor. So all I need to do is click on this arc, and I can go to Create Form, and I can create a curved plane directly from that arc. So this is just a thin little plane right here. Now when I click on this form element, over here on the Properties palette, it has a negative offset and a positive offset. Now for this example, I'm going to dial in explicit numbers and just assume that my bricks are 8 inches deep. But notice that there are the little buttons over here. So we certainly could link these up with parameters, but I think by now that you've maybe had your fill of parameters for the time being. So we're going to go ahead and just dial in some direct numbers in here. I'm going to put in a negative offset of 8 inches and a positive offset of 0. And when I apply that, you're going to see the arch actually shift the other way. So I'm using the curve at the leading edge here as the front of the arch, and then having it go 8 inches back from that point. Now, you may recall we set up the arch offset parameter a little bit earlier. I'm going to flex that right here. And if I change that to say 1 foot, that's going to actually move the entire arch forward. relative to this line here, which is going to be the insertion point of the family. Let me click it again, change it back to 6 inches. It's going to move the whole thing back. With this parameter here, we're giving ourselves the flexibility to be able to move the entire arch in or out relative to the plane that it's going to be inserted on. So it's going to start off at this plane, and then we can push it in or out using that number. Okay? So I've got this shape here, and now I'm going to turn this into a divided surface. So I showed you that at the start of the chapter. Go ahead and click on that. Zoom in even closer. And you can see that it's divided the thing up into a grid pattern, and we've got these long, thin lines right here, and then these other divisions this way. I don't want to divide it at all in the depth. I only want to divide it along the curve. So I'm going to come over here to the Properties palette, and I'm going to take the U-grid layout and click on there, and there's a drop down of choices. So you can do a fixed number, a fixed distance, maximum or minimum spacing, and you can actually say I don't want any grid at all. So when I choose none there and apply that, you're going to see all of those long thin lines along the curve are going to disappear. We're not dividing in that direction. Now in this direction, the layout is currently set to a fixed number, and that fixed number is currently just 12. Now 12 is somewhat arbitrary. That's just the default number that Revit uses. Well, notice the little button right here? I'm going to click on that, and I'm going to assign that to number of bricks. Now we painstakingly calculated the exact number of bricks that we needed in the previous movie by writing out that very detailed trigonomic formula. So now I'm just going to link that parameter up with the division here, and you'll see that number of spacing, 37 in this case, gets applied to the curve, and those are our individual bricks. If you were to actually measure those, you would find that that's 1/3 of that 8-inch dimension, more or less. It's a little plus or minus because, as we talked about, we're rounding the value up. But that's roughly 1/3 of 8 inches or brick size. So we're using that number in there for the width of the brick, and we've got the 8 inches back here. And so that means that the height that we want here is about 4 inches, 3 5/8, because we're essentially setting up a row lock situation here. So in the next movie, we're actually going to go in and apply some geometry along there to represent the bricks and start seeing how the arch is shaping up. So the only thing our brick arch is missing right now is some bricks. So our bricks are actually going to be panels loaded in to each of these divisions that we've created on this divided surface. So the methodology in the massing environment is that you create these surfaces, you divide them up, and then you load in panelized geometry to rationalize the surface. I thought about it and I said, well, that's pretty much exactly what I want to do with bricks, and so that's why we're going at this approach here. At the moment, it says no pattern. If you open up this list here, in the massing environment, they have all of these built-in patterns. What we need to do is actually go in, we're going to use the rectangular pattern. We need to go into the rectangular pattern and create a panel family. And that's going to be of a single brick. And then that panel is going to get loaded in here and give us our individual bricks. So I'm going to go to the big R. I'm going to go to New and choose Family. Scroll down. And this time I want the generic model pattern-based family template. It's got the gray background, so it is part of the massing environment. And you get this surface out here, and you can see that this is just sort of like all hosted family templates. This is just sort of a temporary surface for your use in constructing the geometry. So this represents the surface that we'll be creating in our project. And they've got this one square in the middle accentuated by these reference lines and these points. And that's the controlling geometry that's going to control the shape of this object. Now, in our case, everything we need here in terms of framework is already here. All I have to do is select this chain of reference lines that's already here in the family template. Come over here and click the Create Form button. And Revit will see two possible forms here. We can either create a box or a surface. Now in this case, I want the box because my brick is 3-dimensional. So I'm going to choose that, and it just extrudes it up and creates a box out of it. It puts a little dimension over here. I'm going to turn that into a permanent dimension. I'm going to select that permanent dimension and label it with a parameter, and I'm going to call this brick height. Click OK. And it defaults to 4 feet, which is an awfully tall brick. So let's go to Family Types and change that to 4 inches. Click OK. And now this becomes a very small, thin little surface. And the reason for that is, if you come out here and you click this rectangular grid pattern, it's actually a 10 by 10 vertical spacing. So it's not that the brick is so short, it's that the size, the width, and the depth is so large. It's up to you. You don't really need to do anything else. This family is actually fine the way it is. We could leave it 10 by 10 because what happens is that's just stand-in dimensions. The grids here, the squares, will automatically conform to the size of the divided surface that we have in the host family. So it's automatically going to become brick size when we load it in. But if you want this to look a little bit more like brick size, you can just simply come over here and put in more rational numbers here. I could say the horizontal spacing is only 8 inches and the vertical spacing is, 2.5, or really, what is it? It's 2 2/3. Right? And when I apply that, it's going to become super small and it looks like brick size. Now, again, you don't really need to do that, but if you want to, if it makes it more understandable, you certainly can. Now, the other thing that you can do as an option is you can actually select the brick itself. Now, you might have to tab into it to get the whole form, and you can actually apply materials to it. For the time being, all I'm going to do is click the button here, add a parameter, and just call this brick material, but I'm not actually going to assign it to anything. I'm just going to use that as a placeholder. And then let's save this as, and I'll just call it brick and save it. Probably the simplest family we've created in the entire course. Let me load it into my project and go back to my 3D view. Select the divided surface, click on the drop down here on the properties palette, and notice that under rectangle now is brick as an option. So the rectangle default family now has a sub option of brick, and when I choose that, you're going to see a bunch of bricks appear along the arch. And there they are. Now, of course, we have to flex this thing and see if it's behaving. Let's shrink this guy down a little bit so we can get a better look. And let's choose one of our other sizes here. Apply it. And everything is functioning. And if you followed along with me this far, congratulations. You now have a fully parametric brick arch. Now, there's plenty more that we can do with this. We could add actual materials to it. We could make different brick setting positions like row lock and soldier and double row lock and so on. I've done some of this for you in a sample file that's provided with the exercise files. So feel free to open up that sample file and poke around and reverse engineer it and take it as far as you like. But with that, we're going to complete the exercise and enjoy it. Well, I'd like to thank you for spending time with me exploring the Revit Family Editor. I sincerely hope that you found this course rewarding and that you learned something that you can begin using in your Revit projects. Practice what you've learned. Pull out a sketch pad or an iPad or whatever you have handy and plan out your first family. Think of an object that you would like to have or that you would find useful, or rebuild one that you already have from a previous project. Just remember, the Family Editor can be complex and challenging. So start small, start simple, and slowly work your way up. Furniture is a great place to start. Furniture is freestanding, and many furniture items are relatively simple forms and only have a few parameters. There's nothing like the feeling of completing your first successful piece of family content. Trust me, you'll be hooked. So good luck, send me a screenshot, and I'd love to see what you build.